Good morning, everyone. So, we are going to start with the topic atomic structure or basics of atoms. So, what we had started last day, what was the history of atom? How we started to study the atom from the very beginning. So, it all started in, I am just going through a recap of few points of yesterday. So, it started in 1804 with John Dalton when he discovered atom. Okay, so atom was discovered in 1804, and what we said at that time, we were not prepared to study such a small particle. What were scientists studying? Then we started to study conduction of charge. Conduction of charge, and this was first of all done successfully in 1896. After that, we had discovery of electron and proton in 1909 by Thomson and Goldstone. Once we had electron and proton, then we started for the arrangement of electron and proton in the atom. So this was the history till where we had studied last day. So these 3 or 4 topics are history or story about their discovery we have studied. Now arrangement of atom, we had went through 2 different model that we will study in detail later on, plum pudding model, and then we had solar system model. So after the failure of solar system model, then we came up with the Bohr's model. Now I am not going to discuss the complete Bohr's model, just few basic things about it. What Bohr's model said? Bohr's model said that all the positive charged particles, that means protons, as neutron was not discovered at that time, so all the positive charged particles will be in the center and electrons will revolve around them in a fixed circular path that was known as orbit. So orbit, what is orbit? Orbit is a fixed path in which electron revolves around the nucleus. Now a few interesting thing about orbit. First thing, it is a circular path, fixed circular path. Second, it is also called as energy level. That means whenever electron is revolving around the nucleus, it will have a certain energy and that energy will remain fixed. So each orbit was attached with fixed energy that will not change. That can change only if electrons gain some energy or lose some energy due to some external factor. Till there is no external factor, electrons will keep on revolving in this around this nucleus in this orbit. So this was the first definition for the orbit, and this was the basis for our Niels Bohr's atomic model. But later on, it was found that we can't see electron, we can't find the exact position and momentum of electron at any point of time. That means if I say ki I have, what it means, last model after this was quantum model, that is the ultimate model till now. What it says ki okay, electron is revolving around the nucleus, but electron is so small that you can't exactly pinpoint the position and its velocity or momentum at any given point of time simultaneously. That means you can't pinpoint whether the electron is here and in which direction it is moving, both at the same time. For example, understand why we need it. If any substance is moving, it is moving in a 3D, and you want to pinpoint its position after some time, what we need? If I want to know what will be its position after, let us say 10 seconds, 10 minutes, what we need? We need its present position, and we also need its present velocity or momentum. To find the position of any point, of any particle moving in 3D, after some time, we need its present position and present velocity. But for electron, this is impossible. That means what it says, what quantum model said, कि you can't pinpoint the position and momentum of electron at the same point of time. That means we can't be sure whether electron is here or not. What key we can be sure of? We can be sure of that electron can be somewhere in this region. That this electron can be somewhere, it is revolving around it, it is not on a fixed path. It can be somewhere between this position to this position, that means it can be somewhere in this region. All these points are the possible position of electron at different point of time. So now, as we see, first word that we started with for the orbit, fixed circular path, it went wrong. Why? A fixed path can be possible only if we have a fixed pinpoint position of any particle. We don't have that. What we have, see, all these dots are not different electron. These are same electron at different time. At one moment it is here, another moment it can be here, another moment it can be here. So what we can say is this electron is present at any position or in the region between these two lines. It is not 100% surety, it is maximum probability. And this region of where the probability of finding electron is maximum is known as orbital. So today our topic will be discussing between orbit and orbital. We have to understand what is the difference between orbit, between Bohr's orbit and our Heisenberg or quantum model orbital. We have to understand the very basics of this. So what is the first difference? First difference is orbit is a fixed path, where orbital is a region. Orbital is a region where you can find the electron. You have maximum probability of finding the electron. There is no surety of finding the electron. Okay? There is only probability of finding an electron at any point of time. So orbit and orbital. Now let's say we have an electron. It may be revolving in the orbit, maybe in the orbital. Later on we call it as orbital. So electron, as it is not fixed, this word has been changed to electronic cloud. And orbit, that was a fixed path, it gave way to orbital. Till now we know only one thing, that is what is orbital. Orbital is a region. Why we went to orbital? Because we can't find the exact position of electron. If we can find the exact position, then it must be orbit. If it is not, then it is orbital. And electron can't be pinpointed, that's why it is revolving in orbital. That means we can't guess the position of electron, we can just find the cloud of electron. So it is electronic cloud. Now every orbital is defined by a set of 4 quantum numbers. 4 numbers you can say, and these numbers are called as quantum numbers. For any orbital, if you want to define an orbital, if you want to define a region of finding electron, then it will be defined by 4 different numbers, and those numbers are called as quantum numbers. Quantum number can also be defined as the address of the electron. It is also defined as the address. Why? Because what we are trying to find? The region of electron, where it is located. So that is the address of the electron. So quantum number is of set of 4 numbers. There are 4 types of quantum numbers. 4 types of quantum numbers. They are principal quantum number, n, we have angular quantum number, also known as azimuthal quantum number, L. We have magnetic quantum number, ml, and we have magnetic spin quantum number. These four set of quantum numbers are, first one is principal quantum number, second one is angular quantum number, third one is magnetic, and last one is spin quantum number, also you can call it as magnetic spin. Now for reference, this will represent our energy level, or you can say it as in a simple way cell. This will represent our subshell, and this will represent our orbital. Whatever you are saying, the orbit, cell, orbit, energy level, this will be represented by principal quantum number. Angular quantum number will represent subshell, and magnetic quantum number will represent orbital. Now let's go in a little detail of this. So we will start with principal quantum number, that is denoted by n, and its value is from 1 to n. It can be anything. It can be 1, 2, but integer. 1, 2, 3, 4, 5, so on. And it defines the orbit, or you can say cell, defines the size and energy. So what we are defining, first of all, energy of electron. Okay, size of orbital. It's not size of electron, it's size of orbital. That means we can say if n is 1, that is our k cell. If n is 2, it is second orbit, that is L cell. If n is 3, that is our third orbit, that is M cell. N is 4, this is our N cell. So n, small n, principal quantum number, is defining what? It is defining size, energy and orbit. And each and every principal quantum number will signify a specific orbit, a specific energy level. Okay? So first of all, what we have to find? If you have to find any electron, what you will define? You will define the orbit, at which position with respect to nucleus you can find it. Once that is done, then we go to angular quantum number, L. That is angular quantum number. And its value depends upon n. Depends on n. That means value of any L will depend on n. What does that mean? If, okay, value of L is from 0 to n minus 1. That means if n is 1, if n is 1, first cell, k cell, then what is the possible value of L? Possible value of L will be what? 0 to 1 to, what it says? 0 to n minus 1, that means 0 to 0. Only one number is possible, that is 0. If n is 2, then we have possibility of L equals to 0 and L equals to 1. If n is 3, L equal can be 0, 1, 2. Now if n is 4, L can be 0, 1, 2, 3. Now one thing you must understand, these numbers are a representation. Here 0, 1, 2, 3, these are not representing any algebraic number. You can't go for the algebraic calculation on that. What does they represent? Just keep in mind, each value of L represents a specific shape of orbital. Now we are coming to a second level. First level was what? N, principal quantum number. Now principal quantum number, what it signified? It signified size of the orbital, energy of the orbital. Now L, what does it signify? Shape of the orbital. So first level we defined size, then we came to shape. Now each and every quantum number that is L equal to 0, it represents a spherical shape. A spherical shape, and it was named as S. Its spherical shape was named as S. L equal to 0, it is just a representation. That means only one type of orbital. The first orbit have only one type of orbital, that is 0, that is spherical, that is S. So 0 is a representation for S. Okay. Now L equals to 1. What does it represent? It represents dumbbell shape. Dumbbell shape. That means it will be something like this. And it was named as P cell or P subshell. L equals to 2, it represented double dumbbell. These are different shape that was represented, it was named as D subshell. And L equals to 3 was diffused on all three axes. We can't draw the diagram on 2D. So just I am writing the name. L equals to 3 was named as F subshell. Similarly, if you move on, L equals to 4 will go for G subshell and so on. Now understand from here what we said. When N was 1, for the first cell, for the K cell, for the first cell, only one type of subshell was possible, that is 0, that means S. Right? For second, we have two types of possibility. We can have 0, we can have 1. That means we can have S as well as P. For 3, we can have three different type of shapes, that is 0, 1, 2. That means we can have S, we can have P, we can have D. So now if I conclude from here, in the first cell, that means in the K cell, what type of subshell we have? S only, so 1S. In the second cell, L cell, what we have? Two type of subshell. What are they? 2S and 2P. Right? For L equals to, for N equals to 2, we had two possibility. For N equals to 3, now I have three possibility. We can have S, we can have P, we can have D. So we will have 3S, 3P, 3D. For N subshell, sorry, for N orbit or cell, we can have 4S, 4P, 4D, 4F. So we have crossed two labels. First label was what? Cell. What it defined? It defined the size. Right? Now what does that size means? Now see, I have 1S, 2S, 3S, 4S. Now the word S, that is shape. S is representing what? S is representing shape. What type of shape? Spherical shape. So S here, L equal to 0 is representing a spherical shape, right? And 1, 2, 3, 4, these are different numbers. They are representing what? They are representing principal quantum number that will define size. That means if I draw 1S, it will be something like this. If I draw 2S, it will be something like this. If I draw 3S, it will be something like this. So see, as S is same, as our angular quantum number is same, so shape is same. But as principal quantum number is varying, it's changing, so its size is also changing, its energy is also changing. It will have lower energy than this, than this. That means if we talk about energy, 3S will be more than 2S, more than 1S. 3, 2, 1. Different principal quantum number, different energy, higher quantum number, higher energy. Now if I take it to P, so we can have 2P. So shape of 2P will be something like this, and shape of 3P will be larger. Same thing goes for D, same thing goes for F. So now for the first two level, let's again recap everything. First thing was what? Principal quantum number. What it said? It said us about the energy, about the orbit, about the cell, right? It defined the size of the orbital, and its value was from 1 to n, any integer is possible. Okay, then we come to angular quantum number, azimuthal quantum number. What it is depending upon? It is depending upon n, it is depending upon principal quantum number, and each have a value that is from 0 to n minus 1. That means value of L is depending upon value of n. For n equals to 1, L is 0. N equals to 2, L is 0 and 1, 0, 1, 2, 0, 1, 2, 3. Now these are not algebraic number, these are just a representation. What for? It is representation of shape. Okay, and for shape, if we go, 0 is representing a spherical shape, it was named S. L is 1, it is representing dumbbell shape, it was named as P. L equals to 2 is double dumbbell, it was named as D. And as for 1, we have only 0 is possible, so 1s is possible. Can we have 1p? Is 1p possible? Is 1p possible? Because here n is 1, L equals to 1. This is not valid, because for n1, L must be less than 1. Now if someone says for n equals to 4, can we have d orbital? For d, L is equals to how much? 2. It is less than n, so it is possible, right? For fourth orbit, d is possible. Fourth orbit, f is possible. But for second orbit, if someone asks, is d is possible? No. Why? Because for n equals to 2, L can be maximum 1. It can't be more than principal quantum number or equal to principal quantum number. Okay, so we are done with the first two quantum number. We have a little bit idea of what it is, or better we can say what it signifies. That we have idea. Now we will move to the third quantum number, and that is magnetic quantum number. That is ML. Now if I have magnetic quantum number, this ML value is from minus L to plus L. That means its value depends on L. Value of ML will depend upon value of L, and ML, it represents what? It represents or signifies 3D orientation. In space. What does it signify? It signifies 3D orientation in space. Okay, now let's go for value first. So for L equals to 1, ML will be minus 1 to plus 1. That means minus 1, 0, 1. Okay, I have missed L equal to 0. I will just write down below it. ML can be only 0. For L equals to 2, ML will be minus 2, minus 1, 0, 1, 2. For L equals to 3, ML will be minus 3, minus 2, minus 1, 0, 1, 2, 3. Now again, these are not the number. They are not algebraic number. What are they? They are representation. What do they represent? They represent 3D orientation, arrangement in 3D space, how these orbitals are arranged. Now for L equals to 1, that means for p orbital. What we are talking about? L equals to 1 was p orbital. For p orbital, ML 3 value are possible. 3 different value means 3 different orientation is possible. Now let's see how. Let's start with ML equal to 0. When L equal to 0, this was s orbital. We have only one value. What does this one value means? That means it can have only one orientation. Can have only one orientation. It can have only one possible orientation because it is spherical, it is symmetrical. From any direction if you look at it, it will be the same. That means s orbital will have only one possible orientation. Okay, it can have only one possible orientation. Now L equals to 1. What are the possible value of ML? -1, 0 and +1. How many possible orientation are there? 3 possible orientation. We can have 3 different possible orientation. That means p orbital can be present at y-axis. It will be called as py. It can be present at x-axis, will be called as px, or it can be present on z-axis, and that will be pz. So each of the number is representing a fixed orientation. That means L equals to 1, p orbital have 3 fixed, can have 3 different orientation. It can be either along y-axis, along x-axis, along z-axis. Okay. Now for L equals to 2, for L equals to 2, what ML value I had? ML value possible was -2, -1, 0, 1, 2. How many orientations are possible? 5 different orientations are possible. We have 5 different orientations. 5 different orientations. What are they? First, it can be between x and y axis. It will be called as dxy. Second, I am just changing this axis. This will look similar, but it is axis is different, x and z. Then if it is between this, it will be called as dxz. And if this is between 2 different axes, y and z, it will be dyz. See, all of them are looking similar, but I have changed the axis. First one I have kept x and y because it will be a 3D diagram. Okay now? So second one I have taken xz. Next I have taken yz. So 3 of them are like this. Then 2 are on the axis. One can be like this. This will be called as dx2 y2. We don't call it x square minus y square because that will be something similar to algebraic. So we call it as dx2 y2, and then we have dz2. This is like this. Here we have only 2 lobes. Rest 2 lobes are confined to make a circular plate like or hollow plate like structure. So we have 5 different orientation. Out of this, 3 of them are dxy, dxz, dyz, and rest 2 are dx2 y2 and dz2. Now all these 3 are between 2 different axes, y and x, x and z, y and z, and these 2 are on the axis. So this is a part of our further study. Just we can say all them are non-axial, between the axis, not on the axis, and dx2 y2 and dz2, these 2 are axial. So 5 different type of orientation is possible for d orbital, and for f orbital as L value is 3. How many orientation will be possible? -3, -2, -1, 0, 1, 2, 3. But as they are diffused on all 3 axes, we can't draw the diagram. That is not a part of our syllabus. So 3 different quantum numbers we have studied. Now let's sum up once again. Now let's go for the all 3 level. N equals to 1. When n was 1, let's keep it as n, L and ml. When n was 1, possible value of L was what? 0. Possible value of L was what? 0, and ml was 0. That means we will have 1s. right? For 2, we had 2 possible value. We can have either 0 or 1. That means we can have 0, we can have -1, 0, 1. That means for second orbit we will have 2s, we will have 2p, and this 2p will be 2px, 2py, 2pz. Okay? For 3, we had 3 different levels. We can have 0, we can have 1, we can have 2. For 0, only one orientation was possible, for -1, 0 and +1. And here -2, -1, 0, 1, 2. So what are the possibilities? For 3 we can have 3s, we can have 3px, 3py, 3pz. We can have 3dxy, 3dxyz, 3dxz, and similarly we can have 3dx2y2, 3dz2. Okay? Now I have divided into 3 levels. First level will be called as orbit. Second will be called as suborbit or subshell. Third will be called as orbital. This is representing size, this is representing shape, this is representing our orientation. Now what I mean by orbit, suborbit and orbital. Now anyone ask me, what is this 3p? What is this 3p? Is it orbital? Actually 3p is consisting of 3px, 3py, 3pz. Right? Each of them separate, it is one orbital. It is also orbital, it is also orbital. Then what is this? It is subshell. So if anyone asks me 3p, it is subshell or suborbit. Now when n was 3, we can have 3s, we can have 3p, we can have 3d. Now this is our orbit. So if I am calling third orbit, the third orbit means collection of all of these. Third orbit means we will have 3s, we will have 3p, we will have 3d. All together they are one orbit. When you go to the second level, if I am talking especially about 3p, then it is a suborbit. In that suborbit, if I am talking specifically about px, then it is orbital. So there are 3 different layers. Okay, first layer is orbit, that is group of all the suborbits present. Okay, orbit will be defined by principal quantum number. Number of suborbit will be defined by angular quantum number. And each suborbit can have different orbitals that will be defined by magnetic quantum number. Okay, so I hope this is a little bit clear कि what is orbit, what is suborbit, what is orbital. Okay na? Now last quantum number that we have to study is magnetic spin quantum number. Magnetic spin quantum number. First thing, for every quantum number I said कि it has some significance. For example, principal quantum number was signifying what? Size. It was signifying what? Orbit. But magnetic spin quantum number does not have any significance. It does not have any significance. Then what it is? Value of ms can be plus half or minus half. Why it is taken as plus half or minus half? What does this represent? Again, that is not a algebraic number. What does this signify? In fact, each orbital can have maximum 2 electrons into it. Each orbital can have maximum 2 electrons. Now, both the electrons always remain together. In an orbital, if I have 2 electrons, both of them will always remain together. So, both as one unit is represented as 1. Both the electrons are represented as 1 unit. So each of them will be represented as half. So what does this half signify? This half signifies that 2 electrons will stick together into an orbit, not actually stick together, will remain together into an orbit, and as they are together revolving around the nucleus, they are taken as 1 unit, each of them is represented as half. Now both the electrons rotate around their axis in opposite direction. So both of them are rotating in opposite direction. One is rotating clockwise, another one is anti-clockwise. They are opposite. That is represented by this plus and minus. That means 2 electron, both has 1 unit, taken as 1, will be present in an orbital, and each orbital can have maximum 2 electrons. Each electron will be represented as half, and plus minus represent what? Their opposite direction. And now one more thing, now it is also not sure that plus 1 is representing what? What we said, we have 2 electrons, that is 1, each is half, both are opposite, that means plus minus. Now which one is plus, which one is minus, that is also not clear. They are just for representation that they are opposite in nature. So if anti-clockwise direction is represented by plus half, if the electron revolving in anti-clockwise is represented by plus half, then clockwise will be represented as minus half. If and then. And if anti-clockwise is represented as minus half, so clockwise will be plus half. Okay. So plus and minus, no significance, just representation of 2 electrons in opposite direction. In which direction? No significance. Okay. So these are 4 different quantum numbers. Now understand what it is, why we called it as the address of the electron. Let's have a little bit clarity of that. Now let's say if we write for sodium, we have 281. Okay. So it is our first orbit, it is our second orbit, it is our third orbit. Right now, if I have to find the 6th electron, let's say I have to find the 6th electron of sodium. Okay, where we will go? Will we search in the first orbit or in the third orbit? If I have to find the 6th electron of sodium, first of all, what I will do, I will go to the second orbit. That means I will go to n equals to 2. Now when I reached n equals to 2, when I reached that orbit, what I found? I found that there are 8 different electrons revolving. What I have to find? Only one of them. Then I divided it further into 2 parts. In second orbit, what was possible? 2s and 2p. Right? In 2s, only one orbital was there, where here we had 2px, 2py, 2pz. Right now, for second orbit, what was possible? 2s and 2p. For 2p, how many orientation possible? 2px, 2py, 2pz. What I said, each of them is one orbital. Px is one orbital, py is one orbital, pz is one orbital. And in the last page what we said, कि each orbital can have maximum 2 electrons. That means here I will have 2 electron, here I will have 2, here I will have 2, here I will have 2. Now to find the 6th electron, what I did? I went to second orbit. That was level 1. What I defined, as I said second orbit, what I defined principal quantum number 2. So I went to principal quantum number 2. Now, after that, let's say here we had 2 electron, 4, 5th and 6th. 5th and 6th. So 6th electron will be where? It can be anywhere, that we will see detail later on. Right now, let's say that is in 2px. So where I will go? From n equals to 2, I will go to n equals to 2, L equals to 1. Second level done. Then where I will go? N equals to 2, L equals to 1. Then I will go to one value of ml. -1 or +1. Now, here we will find that as I have crossed 3 level, I crossed first level, I crossed second level, I crossed third level. After crossing all this level, I reached a small, let us say, house where I found 2 electrons over there. Right now, I was searching for the 6th one. I crossed first one, I crossed second, third, fourth. When I reached here, what I found? I found there were 2 electrons. One was rotating clockwise, another one was anti-clockwise. If I have to catch that 6th electron, I have to go for the last one. That is either msh plus half or msh minus half. So to find any electron, to find the address of any electron, we need to have all the 4 quantum numbers of that electron. If you have all the 4 quantum numbers of that electron, then we can define a certain specific electron with that 4 different quantum numbers. Okay, so I hope that's clear for everyone. What is orbit? What is suborbit? What is orbital? What is spin quantum number? Why we came to this? Because we started from orbit, but it failed, and then it came to orbital level. What was orbital? Orbital was a region where probability of finding electron is maximum. From that orbital, I moved on to quantum number. Why? Because to find any electron, we need a quantum number. For any orbital, we need a quantum number. So there are 4 quantum numbers, and each quantum number has its own significance, and they define a specific prospect of any electron revolving around the nucleus. Okay? Now, if we have some doubt about what is this S and P, just a layman language, if I can make you understand, let's say I am in the 3rd orbit. I am just trying to make it understand at your level. Okay, okay, leave it. Let us go for the 2nd orbit only. So I am in the 2nd orbit. Now try to understand as just an example, a way to make you understand. In 1st orbit, I will have how many electron beta? Maximum 2. 2nd orbit, how many we can have? 8. In this 2nd orbit, some of them was revolving in 2s, some was revolving in 2p. From 2s, from 2p, we will have 2px, 2py, 2pz. Now what I had initially said, you can't pinpoint the position of electron. Now what I did, I made one person stand over here, and I said about the p electron. I showed him one p electron. I said this is the electron, you have to pinpoint it. So this person has to study 2p electron, and here this person has to study 2s electron. What they have to study? They are standing over there. They are trying to find the position of electron at after each second, after each fraction of second. So this person started locating. First time he saw it here, second time here, third here, fourth here, fifth here, like this. So what are these points? These points are representing the position of electron at different point of time. So he started pinpointing all those things like this. So he started pinpointing all those things like this. these electronic cloud, these electronic are the positions. Okay, these are the positions of electron. This person is pointing the position of electron whenever he is trying to find, matlab whenever electron is crossing it, he is trying to study it. And as we can't pinpoint the exact position, that means every time he will find a new position. So he pinpointed all those positions for, let us say, some time, some point of time. And this person was also studying another electron, and he also pinpointed the position. Now, what I had said, what is orbital? Orbital is the region where probability of finding electron is maximum. As we can see, maximum electron is in this position. Right? This region is for for the electron that he was studying. What he found, that maximum electron is found in this region. And what this person found, that maximum is in this region. This is spherical shape. That was for s orbital. And this is dumbbell shaped. That was for p orbital. So I think a little bit clarity ki p got a dumbbell shaped, s got a spherical shape from where? What does that dumbbell and spherical mean? In second orbit, we will have both 2s and 2p. Now there can be some questions at one point we have dumbbell shape, at one point we have spherical shape. What does that signify? This signifies that one electron, one of those electron revolving in second orbit will have probability to be found in a dumbbell shape, whereas another one will have probability to be found in a spherical shape. That is spherical one is 2s, that dumbbell shaped is 2p. So that was all about the quantum number. I hope that is clear for everyone. What is quantum number? What are different quantum number? What does they signify? Now each quantum number has a meaning except ms. What do you mean by shape? Similar to this, some electron will be found on x-axis, some will be found on y-axis, some will have probability on z-axis. So we will have px, py, pz. What does that orientation mean? That is also clear. Okay. So quantum number is over. Now, what is orbit and orbital? If I talk about difference between orbit and orbital, it's less visible. Orbit and orbital. What is the basic difference? It will be a fixed path. It will be a region. Right? It talks about, what does orbit talks about? It talks about the certainty of finding electron. I'm just talking about the basic difference. I'm not going about the complete sentence. I'm just talking about what is the basic difference, what is the conceptual difference. And it talks about the probability. Okay? It was a part of Bohr's model. And it was a part of quantum model. So this was the basic difference between an orbit and orbital. For our level, we will say orbital is the region of probability of finding electron. A group of orbitals will be called as suborbit. Group of suborbit will be named as orbit till our level. Everything is orbital. Why? Because they are electronic cloud. There is no certainty. As this word ends, orbit ends. Okay? Chaliye. Next. Now we have to study about the energy of the electrons in these orbitals. Till now what we know? Till now we know if an electron is revolving here, first orbit, it is second orbit, it is third orbit. This we know. right? So first orbit, what we will say, energy of third orbit, if we talk about energy, third orbit is more than second orbit, is more than first orbit. This we know, right? Why? Because from the distance from the nucleus, we can say that as distance is increasing, energy will be increasing. As energy increases, electron will move away from the nucleus. So third orbit will have more energy than second, than first. But now one more thing is there. In third orbit, we don't have all energy same. Why? Because now we have 3s, 3p, 3d. In second, all is not same. Why? Because we have 2s, we have 2p. So now we will go to energy of orbitals to the next level after orbit. Till orbit we know, right? Now that means we are now going to find the arrangement of orbitals on the basis of their energy, and this was given by of Bohr's principle. Now what does of Bohr principle says? It says, okay, I am not going about filling. First I will talk about energy, then we will talk about filling of electron. First it says, the orbitals having larger value of n plus L will have more energy. The orbitals having larger value of n plus L will have more energy. But if n plus L is same, then what? If value of n plus L is same, then larger the value of n, more the energy. So for us right now, Bohr principle of just two lines. What first line says, for any value, for any electron, if it is given, we can find n and L, principal quantum number and angular quantum number, right? See, ML is not a part of this, MS is not a part of this. Right now we are just talking about n and L. So first, higher the value of n plus L, higher the energy. But if for any orbital, value of n plus L will be same. If the value of n plus L becomes same, then what? Then we will check value of n only. Then more the value of n, more the energy. Let's go for calculation and example. For first orbit, I have 1s. For second orbit, I have 2s, 2p. For third orbit, I have 3s, 3p, 3d. For fourth orbit, 4s, 4p, 4d, 4f. For fifth, 5s, 5p, 5d, 5f. After that, I have 5g. This will not be used because we are just going to study all the elements still found in periodic table. So G will not be a part of this for us. What is the value of n over here? N is 1, S. S was represented by L equal to 0. So if I am talking about n plus L, it will be 1 plus 0. Understood why I have written this 1 plus 0? N 1. First number, that is representing principal quantum number, that is representing orbit. So 1s, n is 1 and L is what? 0, right? L was what? Angular quantum number. And for s orbital, value of L was 0. Again, for this it will be 2 plus 0, 2, 2 plus 1, 3, 3 plus 0, 3 plus 1, 3 plus 2, 4 plus 0, 4 plus 1, 4 plus 2, 4 plus 3, 5 plus 0, 5 plus 1, 5 plus 2, 5 plus 3. So I am just writing the value of n and L. Whatever number I am getting, I am adding them. Okay. So which one is the lowest value, least value? 1. The lowest energy will be for 1s. Now this is 1, this is 2, then we have 3. So second energy will be 2s. Now for 2p I am getting 3, and for 3s I am getting 3. N plus L value has become same. So if the value is same, then what we check? We check the value of n only. Which one is larger? 3s is larger. As 3s is larger, so its energy, 3s means 3 number. First number, principal quantum number, n is larger. So 3s will have more energy, 2p will have lower energy. Okay. Now after 3 plus 1 4, 3 plus 2 5, 4 plus 0 4. So 3p and 4s had same value. 3p and 4s has same value. Which one is having larger n? 4. So that means 3s. After that we will have 3p. After that we have 4s. Now 3d is having value 5. So it has overcome 4s. Now 4p is 5. This one is also 5. Right now? The 4 plus 1 5, 3 plus 2 5. This 3 is smaller. So we will go for 3d than 4p. Now 4d is 6. 4f is 7, but here we have 5s, 5, so it will go for 5, then we will go on like this. So energy of electrons present in a certain orbital will be 1s, lower than 2s, then 2p, then 3s, then 3p, then 4s, 3d, 4p, 5s, so on. Okay? Now what about this 2p? What about this 2p? It also considers 3 different type of electron. One is 2px, one is 2py, one is 2pz. What about them? Now if I say 2p has 2px, 2py, 2pz, energy of all of them are equal. Energy of them are equal, and they will be called as degenerate orbitals. So 2px, 2py, 2pz are degenerate orbitals. But if I talk about 3s and 3p, are they degenerate? No, they are not degenerate. Because their energy are not same. All the orbitals present in one suborbit will have same energy. So if I want to draw it like an energy level diagram, how it will look like? Lowest energy will be for 1s, then we will go for 2s, then energy will increase for 2p. In 2p we will have 2px, 2py, 2pz. Okay? Each circle is representing one orbital. Then we will have 3s, then we will have 3p, then we will have 4s, and here we will have 3d. Here again I am drawing it in 3 circle. So this will be the energy diagram. 1s, only one orbital, 2s. Now these 3 are degenerate. Each level, each staircase, each step of that staircase is representing degenerate orbital. So 3px, 3py, 3pz, these will be degenerate. Again here, all of them are 3D. One will be xy, one is yz, one is xz, one is x2, y2, and one is z2. All of them are degenerate. So if someone asks number of degenerate orbitals in 3D will be how much? 5. In 3p will be how much? 3. In 1s will be how much? 1. So these are degenerate orbitals. So till now what we have studied today, let's start from the very beginning. Once we will recap everything what we have done. So we started from the very word atom, from the word atomos, that means indivisible, that means 1800. 1800 What it was said, atom was the smallest particle, you can't further divide it. And till 100 years there was no more discovery on it. But in next 20 years, 30 years, everything changed. For 100 years there was no discovery. 100 years there was no question rising on even indivisibility of atom. But in next 30 years, we went on through different number of models. We got first model in 1909, right? Then we moved to Bohr's model. What does Bohr's model say? It says that electrons revolve around the nucleus in a fixed path that is known as orbit. But just after that, what we found? Electron can't be seen, electron can't be pinpointed with respect to its position and velocity. And that's why we came to a region of finding electron that was known as orbital. Right? So, after orbital, what we know? If I have to study any orbital, so we need 4 different numbers, and those numbers we will call as quantum numbers. What are these quantum numbers? These are address of an electron. These are the address where you will find a specific electron. So 4 quantum numbers were principal, angular, magnetic and spin. Okay. So after that, principal quantum number defines size and energy. Angular quantum number defines shape and it depends upon n. What was the shape? For L equals to 0, it was S. For 1, it was P. For 2, it was D. For 3, it was F. So different type of shape we have seen. How size and shape will differ, that we have seen. Then we came to magnetic quantum number that tells us about the orientation in 3D space, how you orient them, how you arrange them in 3D. Right? So different type of orientation. For S, we have only one orientation. For P, we have 3 different orientation. For D, I have 5 orientation, and for F, I have 7 different orientation. Now each orientation is a orbital. Group of these orientation that was in L will be suborbit, and group of all those suborbit will be an orbit. So this was a sum up. For the first orbit, I have 0. That means I will have only 1s. For second, I have 0 and 1, 2s and 2p. Again in 2s and 2p, we will have different orientation. Okay, so I clarified about subshell, suborbit, orbital. Then we came to magnetic spin, the last one, that signifies just the presence of 2 electrons in one orbital and both rotating in the opposite direction. Right? They do not have any significance. Then we tried to find what is the physical meaning of this. What do you mean by them? By this, what? Principal quantum number, angular quantum number and magnetic quantum number. So we tried to have a little idea about that. If I have to find electron, what is address, where we have to go, how can I find each and every electron. Then we tried to learn a little bit about what these shape, where it came from. What does it mean for us when we are studying a atom. So difference between orbit and orbital, and last we came up to the energy, that is of Bohr principle. What is the energy of these orbitals? How to arrange them in the increasing or decreasing energy. So that will be our last topic for today. Now we have studied degenerate orbital. So now what we will start with, from the next class, now we have orbitals. We have understood what is orbitals. We have understood what is the energy of orbitals. We have understood how are they arranged. Okay. Now let's say I have a fixed number of electron. I have an orbit or I have an atom that is vacant. I have to fill them one by one. I have to fill electron one by one into that orbital. So our next topic will be filling of electron. From the next class we will start from here, filling of electron into an atom. How to fill the electron, how the electrons are arranged. If atom is completely vacant and I am throwing one electron one by one, so where it will land? Where will first electron go, then second go, then third go, then fourth go? Okay, so now we will start with the filling of electron that will be ultimately giving you electronic configuration. And after that we can start with any topic of chemistry, because once you know the electronic configuration, then we can start with any element, reaction of element, why they have having some specific properties, why they have that physical property, why they have that chemical property. So this will be our next topic, filling of electron and electronic configuration. So that's all for chemistry today. Now you can go for a break. Okay, so bye everyone.
Good morning to all my children. Again today, third day, I am going to start your physics. First, whatever homework I had given you, I will explain to you, and then classwork also I will do, and then further we will study. A child has asked one question related to athlete. Okay, no? I had explained yesterday. Again, let us see what is that problem. You have a person, athlete is there, he is running in a field. One complete round, he is giving in 40 minutes, right now? One full round. There is a field, in field he is running. One full round he gives in 40 minutes. They are asking you his displacement in 1 hour 20 minutes. So let us consider, I am considering one athlete. He is running in a field. Suppose he started running from here. He is giving one complete round in 40 minutes. Right? They are giving you in 1 hour 40 minutes plus 40, 80 plus 40, 120 in 2 hours 20 minutes, what will be his displacement? And they have given you radius 2 meters. In 2 hours, how many minutes you have? 120 minutes. Keep it separate. I am explaining you in other way today. 40 minutes, one round. So from here, athlete started running. He is moving from here and again had come back here. One round, time passed 40 minutes. Displacement, how much? 0. Displacement will be directed line segment in between initial and final position. Now final position and initial positions are same. So displacement becomes 0. First 40 minutes has passed, displacement becomes 0. Now next 40 minutes, again he had come back here. How much time had passed? 80 minutes. Again displacement become 0. Now next 40 minutes, 3 rounds he had already completed. And at the end of 120 minutes, his displacement becomes 0. From where he started running, again he is coming back to same point. It means that in 2 hours, that is in 120 minutes, his displacement is 0. Now, remaining you have 20 minutes. In 40 minutes, he is giving one full round. Then in 20 minutes, he will be giving half round. Means he started from here and he will be reaching here. He is starting from here, reaching here. So this will be initial position and this is final position. Net displacement will be equal to length of diameter. Radius they have given 2 meters. So this is 2 meters and this is 2 meters. Total will be your 4 meters. His displacement will be 4 meters. Now please tell me, did you understand now clearly? I hope you understood it clearly. Now let us go back to our file. We'll be going for Okay, homework as well as classwork. So, so please see now the questions. Define rest and motion. This is your define rest and motion. Today is day 3, no? Already I have explained to you, rest and motion, both are relative terms. There is no absolute meaning of rest and motion. There will be meaning only in a frame of reference. I had explained to you that if a person is sitting in a moving car, moving train, with respect to co-passenger, he is at rest. If your frame of reference is fixed with respect to moving train or moving car, in that frame of reference, a person is at rest with respect to a co-passenger. But if your frame of reference is fixed with respect to ground, he will be in motion. Right? The person is standing on the road and will be seeing that person who is going in car, or a person is standing on platform, he is seeing the moving train. When he will see that person sitting in a moving train, he will feel that that person is moving. The rest and motion are relative terms. If position coordinate of any particle will not change with respect to surrounding, you will say that particle is at rest. And if its position coordinate is changing, you are telling that particle is in motion. Surrounding is basically related to your frame of reference. I have told you frame of reference is of two types, inertial, non-inertial. Mostly we talk about inertial frame of reference. It is that frame of reference which is fixed with respect to Earth, or which moves with constant velocity with respect to Earth. So when we talk about surrounding, it means that we are talking about the objects which are situated on Earth. So if a body is at rest with respect to Earth, we consider that body to be at rest. If it is moving, we will say that body is in motion. The absolute meaning of rest and motion does not exist. Whenever we talk about rest and motion, first we will have to decide frame of reference. I hope you understood it. Let us move now to next question. Is it possible that a particle is at rest and also in motion at the same time? Explain with one example. Just now I have explained to you. If frame of reference is fixed with respect to a moving train, and a person is sitting in the train, with respect to co-passenger, he is at rest. But with respect to a person standing on ground, standing on platform from where train is crossing, with respect to that person is standing on platform, that man, that person sitting in train is in motion. So they are asking you, is it possible that a particle is at rest and also in motion at the same time? Yes, it is possible. It depends upon how you see position coordinate from what type of frame of reference. frame of reference you are changing, body may be at rest, body may be in motion. Is it clear to you? Now, let us move to next question. If the distance traveled by an object is 0, then the displacement of the object, you know, distance will always be positive. Displacement may be positive, may be negative, may be 0, but distance covered in a given time will always be positive. If they say distance traveled by an object is 0, it means that its position coordinate in a given frame of reference has not changed at all. If distance traveled is 0, displacement must be 0. But if opposite you take, if displacement is 0 and distance traveled will be 0 or not, then we can say it may be, it may not be. But if distance traveled by an object is 0, displacement of the object should be 0. So I hope you are understanding now. Distance traveled by an object is 0, displacement of the object must be 0. Now, let us move to next question. If displacement of an object is 0, distance traveled by the object, just now I have told you about this question, yeah, may be 0, may not be 0. For example, I am taking a particle is moving in circular path. Suppose its radius is r. Now they say you displacement of an object is 0. Particle had started to move from here and it had completed one full circle. From wherever it has started, again it had come back there. Displacement becomes 0. But what about distance? Distance is length of the path tracked by the particle. So, it has tracked the circumference of the circle and it is equal to 2 pi r. Displacement is 0, but distance covered is 2 pi r. So, if the displacement of an object is 0, distance traveled may be 0, may not be 0. May be 0. How? Particle is situated here and it has not moved at all. It is at rest. If particle is at rest, displacement is 0 and particle has not moved at all, so distance will also be 0. So your answer will be may be 0, may not be 0. Now, let us move to next question. A particle moves 10 meter towards east. Whenever you will be finding in physics any problem related to direction, east, west, north, south, first you draw like this. This is east, this is north, this is west, this is south. Clear to you? After that, particle moves 10 meter towards the east. We are considering origin. From origin, particle had moved towards east by a distance of 10 meter. Let us suppose it has reached to point A. Moves 10 meter towards east. It has reached to A and this distance is 10 meter. Now, they say you from point A, it had moved 15 meter towards west. So from A, it has come back, from A, it has come back to B. West, from here it has gone towards west. How much? 15 meter. This is your 10 meter and this is your 15 meter. Clear to you? Now, they are asking you displacement of the particle. You know, displacement depends only on initial position and final position. This is your initial position and this is your final position. Directed line segment, direction is this. And simple, how much distance it is? It is 5 meter. They are asking you displacement of the particle. It will be 5 meter towards west. See, direction. This is west. This is final position. This is initial. From initial to final. So direction is west. Now, let us see. You have 25 meter towards east, 5 meter towards east, 5 meter towards west, none of these. I hope you understood the answer. It is 5 meter towards west. Have you followed? May I say it again? You have to consider first from origin particle started moving. First it has gone towards east. How much? 10 meter. And then it had come towards west. 15 meter. Final position is 5 meter towards west. If you consider directed line, directed means from initial towards final position, directed line segment, you are getting 5 meter and it is towards west. First day, I understood that you people will be learning if I explain you slowly. I hope my every child understood. And even if any child is not understanding, again in the same way you tell to me, in my next class I will explain to you. Understood this now? I am moving to next question. A particle moves 3 meter towards east, then 4 meter towards north. Find the ratio of displacement and distance traveled by the particle. I have told you, whenever directions are involved in any problem, first you draw the directions. This is origin, this is east, this is north, this is south, this is west. They say you particle had moved 3 meter towards east. 3 meter means from here it had gone 3 meter. Point A you take, this is 3 meter, right? Then they say you particle had moved 4 meter towards north. This direction is north. So from here it had moved 4 meter towards north. It has reached to point B now. If you want distance traveled, it is length of the path. What is the length of the path? 3 meter plus 4 meter. So distance covered is 7 meter. Simple. 3 plus 4 equal to 7 meter. Now displacement. For that you must know initial and final position. The initial position is here, final position is here. Now directed line. I have drawn line from here to here. Understanding now? Now Pythagoras theorem you know. This is 3 meter, this is 4 meter. already you know displacement will be OB. Displacement, if you take, will be under root 3a square plus 4a square, 9 plus 16, root of 25, this is equal to 5 meter. Displacement is a vector quantity. They have not asked you direction. If they will ask direction, we can also find out that. We will be taking tan theta. Okay, no? This angle will be taking extra, I am telling you. Here, answer is ready. They are asking you ratio of displacement and distance. Displacement 5 meter, distance 7 meter, ratio 5/7. Answer is here. One extra information. Displacement is a vector quantity. We want to know its direction. So this angle theta, if you take tan theta, this will become 4/3. So theta will become tan inverse 4/3. You already know it. It will be 53 degree. So you will be telling 53 degree, you are measuring from east towards north. Clear to you now? First, for this problem, answer is clear, no? 5/7. You want to find out angle for displacement with east, tan theta, perpendicular by base 4/3. Clear to you now? Now let us move to next question. Alekia travels from her home at Vijayawada to Resonance Hyderabad. Very far, no? Yeah. From Vijayawada to Resonance Hyderabad, covering a distance of around 250 kilometers in 5 hours. In my opinion, she should take house in Hyderabad only. From Vijayawada coming here and going back, it's too difficult, no? Anyhow, so here 250 kilometers in 5 hours. So let us suppose this is Vijayawada and this is Hyderabad. For time being, let us take it is along a straight line path. Okay, no? So this distance, anything, they are asking you find the displacement. I am taking it along a straight line path. This distance 250 kilometers, and she has traveled in 5 hours. During her return journey, she had gone back also. Means morning she had come, evening she is going back. During her return journey, she has taken 6 hours. Traffic will be more. 6 hours to go back home. Okay. She started from Vijayawada. She has reached to our Resonance College. And then she returned back here to Vijayawada to her home. They are asking you, find the displacement. What's the need of so much data, beta? From where Alekia started, she has reached to same place. She has started from home and she returned home. Initially, she was at home. Finally, she has reached at home. Initial position and final positions are same. What will be displacement? Already you know it will be 0. Let us see the alternate. 500 kilometer, 250 kilometer, 745 kilometer, none of these. One option they should keep 0 also. It is not there. Which one you will be taking? None of these. Nowadays, none of these options they are not giving in IIT exam. They will be giving all 4 alternate. But here, for this question, which answer you will be taking? You will be taking none of these. Check. They have asked you displacement. They have not asked you distance. If they will ask you distance covered, then length of the path you will have to take. Vijayawada to Hyderabad, 250 kilometer. And again, Hyderabad to Vijayawada, 250 kilometer. He has traveled 500 kilometer, and that will be distance traveled by Alekhya. But displacement becomes 0. I hope you are understanding clearly. Yeah? For finding displacement, just concentrate on initial and final position. Understood? No? Now, this one is over. After that, next, a particle starts from the origin and moves along positive x-axis. So, you have to take first x-axis. This is x-axis. This is origin. I have taken one-dimensional frame of reference, single one axis, x-axis. Particle has started from the origin, means it has started from O. Moves along positive x-axis, means it has moved along this direction. The position of the particle at 3 seconds is 5 meters. So, let us take point A, time taken 3 seconds, and it is 5 meters, means he has gone, particle has moved 5 meters. And at 5 seconds, it is minus 12 meters. So, this is origin, and you will take this direction. This is negative x-axis, and they are telling you minus 12 means this side, negative x-axis side, it is 5 seconds. Okay, at t equal to 5 seconds, it is at minus 12 meter. So this distance is 12 meter. Because it is towards negative x-axis, so you are considering as minus 12 meter. Find the ratio of magnitude of displacement of the particle during 0 to 3 seconds and 3 to 5 seconds. They are asking you magnitude of displacement. First concentrate 0 to 3 seconds. In 0 to 3 seconds, particle, one thing more is there. They are telling you only consider magnitude. We will be considering only magnitude of displacement. So, 0 to 3 seconds, in 3 seconds, my displacement is directly 5 meters. Right? And they say you at t equal to 5 seconds, means only in 2 seconds, particle had moved from A to B, it had come here. Am I right? So 3 to 5 seconds, how much distance particle has traveled? If you consider from A to B, this is 5 meter, this is 12 meter, you are taking only magnitude. So your initial position coordinate from 3 to 5 seconds, at 3 seconds, particle is at A. At 5 seconds, particle is at B. Now, directed line segment from A to B means from here till here. and you should take only magnitude. It is 5 meter, it is 12 meter, total become 17 meter. So, in 0 to 3 seconds, it is 5, and 3 to 5, it is 5 plus 12, 17. The magnitude of displacement of the particle during 0 to 3 and 3 to 5, its ratio is 5 by 17. So your answer is A. Tell me, did you understand clearly? They are not telling you here that 0 to 5 seconds. If they will say 0 to 5 seconds, then I will be considering only minus 12. They are telling me 3 to 5 seconds. The 3 second particle was at A. If they will tell 0 to 5, at 0 second particle was at origin. Difference is there. So whenever you are solving a problem, you must read questions properly. Very simple technique is there to solve a problem. 3 steps. Step 1, you must understand what are given quantities in a given question problem. Step 2, you must understand what they are asking from you. And step 3, try to correlate step 1 and step 2. So here, step 2 is very important to understand. They are asking you, the second term is important. They are telling you whether it is 0 to 5 seconds or 3 to 5 seconds. It is 3 to 5 seconds. I hope you understood. Let us move to next question. When a body covers an equal distance in equal interval of time, its motion is said to be equal distance in equal interval of time, motion is uniform. If unequal distances in equal interval of time, motion is non-uniform. Yesterday I have explained to you. So here, direct a theory-based question you have, equal, equal. Answer will be uniform. I hope you are understanding it clearly. Right? Let us move to next question. The motion of a body covering unequal distances in same interval. Just now I told you now. Equal distance in equal interval, uniform. Unequal distances in equal interval, non-uniform. So here it will be variable. The motion of a body covering unequal distances in the same interval of time is said to be non-uniform or variable. Let us move now to next question. A bus traveled the first 1/3 distance. Now it is class work. Okay, beta? For this class work, I was explaining you today's class work. I will be doing these problems by introducing one more definition of velocity. Yesterday, all of you have told me, I have gone through your all comments, you understood clearly. So what is speed, what is velocity, you know. What is uniform velocity, what is non-uniform velocity, you know. Now, I have to introduce two more velocity. Mean velocity or average velocity. Okay, no? Very simple. If you are considering average speed, it is, you must remember, average speed, this word is here. Average speed, this is beta, total distance covered by my line, you must remember, because here the word which we generally neglect will play very, very important role. Average speed is total distance covered by total time taken. Usually, they will simply say you distance by time. No, it is total distance covered by total time taken. In that, everyone will be considering numerator, but denominator plays very important role. And average velocity or mean velocity is net displacement by total time taken. Total time taken. Observe in these two, the moment anyone is seeing this type of problem, they are concentrating on numerator. They will rush to get total distance covered and net displacement and all. But I want to say you that concentrate on total time taken. This is same for both. In average speed and in average velocity, denominator is same. Total time taken will be common. For example, if I take a particle moving in a circular path with uniform speed v, it had completed 3.5 number of revolutions with uniform speed v, they will ask you what is average velocity. You know that distance covered and displacement will be different. But total time taken, it will be same for both. Whatever time you are taking in average speed, same you will have to consider for average velocity. Clear to you? Now, I hope you are understanding the concept of average speed and average velocity. In this question, you have a bus travel the first 1/3 distance at the speed of 10 km per hour, next 1/3 at 20 km per hour, and last 1/3 at 60 km per hour. The average speed of the bus is. Average speed is total distance covered. Before solving this problem, I want to explain you a bit in more detail this quantity. For this, you consider in this way that a particle is moving along a straight line path. Okay? Half distance it covers with velocity v1, and next half distance it covers with velocity v2. Along a straight line path, if you consider, then average speed and average velocity both will be equal. Understanding now? If you consider along a straight line path, both are equal. Now, if I take total distance covered and net displacement, these two will be equal. So, let us take this is S1. Here I have taken half. In some problem, they will not be half. It will be different. So, let us take S1, S2. This is S1 and this is S2. Then, net displacement or total distance covered, average speed you take or average velocity you take, net displacement will be S1 plus S2 divided by total time taken T1 plus T2. Clear to you? Now, T1 and T2 are not given. You will have to calculate T1 and you will have to calculate T2. Now, to get T1, it has covered s by 2 with v1. How much time it has taken to cover s by 2? T1 will be s by 2 divided by v1, s1 by v1. And how much time it will take to cover next s by 2 or s2? It has traveled with velocity v2. Time taken t2 will become s2 by v2, that is s by 2 by v2. So here this will be equal to s1 plus s2. If total distance they will give, then I will take s, divide by s1 by v1 plus s2 by v2. Clear to you? I want to come back onto this problem. I want to explain you this concept a bit in more detail. I'm taking a new page. Okay? About average speed and average velocity, I want to explain a bit in more detail to you. All type of children are sitting here. So, now, again go back. Average speed, total distance covered by total time taken, average velocity, net displacement by total time taken. Suppose I am taking a particle moving in a circular path of radius r with uniform speed v. Speed is v. Uniform speed v they have given you. It had completed 3.5 number of revolutions. What will be average velocity? If you are noting, please note this problem. It is not given in our CBC book. Okay? But this question they had already asked. So if you are noting it, please note. A particle is moving in a circular path with uniform speed v. When it completed 3.5 number of revolutions, what will be average velocity? So, you are taking a circular path. Suppose particle has started to move from here. It had completed 1, 2, 3.5. Means this is initial position and this is final position. If you take average speed, total distance covered. Now, total distance covered is how much? 2 pi r, 4 pi r, 6 pi r, plus pi r, 7 pi r. So, 7 pi r is 722 by 7 and r 7 cancel. It is 22 r by total time taken. Let us take t. They have given you uniform speed v. The uniform speed v will be how much? 22 r by t. So t will become equal to 22 r by v. Now they are asking you average velocity. Now average velocity is net displacement by total time taken. Net displacement will depend upon initial position and final position. Initial is this, final is this, so this is 2r. And just now I have told you that total time taken is common. It is same for average speed as well as average velocity. So time taken already you have calculated 22 R by V. So this will be equal to R cancelled. It will be 2V by 22. 2, 11 times answer V by 11. Are you understanding how to calculate? Is it clear to you? May I repeat again? Did you understand? Particle is moving on a circular path with a uniform speed v. When it completes 3.5 number of revolutions, what will be average velocity? And your answer is v by 11. You have considered average speed is, okay, total distance covered by total time taken, average velocity as net displacement by total time taken. This total time taken is common. So always concentrate on total time taken. I give you other problem, other example. Suppose a person is started to move from A towards market. You can take his house. From house to market he has moved. So here is house and here is market. Suppose it is at a distance of 5 kilometers. He has taken half an hour to reach there. Half an hour. Half hour he reached to market. Okay, no? And now, in market, 15 minutes he has passed. Okay, no? He stayed in market for 15 minutes. And then he returned back. Okay, no? And when he reached around 2 kilometers, he met his friend. So here he is meeting a friend. He reached 2 kilometers, let us take 10 minutes. Okay, no? And he talked to his friend for 5 minutes. Okay? And then he returned back home. Let us take, after reaching here, he has taken, okay, 10 minutes, 5 minutes. Let us take any time. I am taking 20 minutes. He is walking slowly. Right. If you take displacement, net displacement, then he started from house and he returned home. Net displacement is 0. So his average velocity will be 0. But what about average speed? We'll have to consider total distance covered. Total distance from here till here is 5 kilometers. And again he had come back 5 kilometers. Total distance is 10 kilometers. Okay? Total distance covered by the person is now 10 kilometers and total time taken. This specifically I have told you because in this problem I have taken some time for which person is not moving. If person is not moving, that time you should consider or you should not consider. You must consider that time also. Some children will think, sir, he is not moving. Why we should consider that time? But that time is involved, no. While traveling this 10 kilometers, the time for which he was talking to his friend or he was purchasing something in market, the time is involved. So if you take here, your answer for average speed will be half an hour, 30 minutes, 45 minutes, 55 minutes, 60 minutes, 80 minutes. Total time will be 80 minutes. You cannot take, sir, from here till here he was walking. So half an hour, 30 minutes you take. This 15 minutes, half an hour, 15 minutes, you don't consider, sir. 10 minutes, you consider, sir. This 5 minutes and this 15 minutes, you do not consider, sir. So time taken will be 30 plus 10 plus 20. 1 hour you should consider. No. The time for which he was at rest, that time also must be considered while computing average speed or average velocity. Here, when you have taken from house to market and again back to house, net displacement you have taken 0, so you have told average velocity 0. But if I would ask you what will be his average velocity from house to that point where he is meeting his friend, then there will be net displacement. Your net displacement will be 5 minus 2. Then your initial position is this and final position is this. It will become 3 kilometers. Okay, no. Even for computing average velocity, net displacement you are obtaining now from initial position and final position. This distance you have taken total 5, in that it is 2, it is 3 kilometers. Clear to you? 3 kilometers and time. There is one catch here. Sir, in time, you will consider, sir, this 30 minutes, sir. This one also you have told in market 15 minutes he was there, we will consider, sir. This 10 minutes also we will consider, sir. But what about this 5 minutes when he was talking to a friend? Before starting to talk, person had already reached to that point. So, you should not consider this 5 minutes which he had passed while talking to his friend. If I compute average velocity from point A to that point where he is meeting his friend in return journey, I will consider time only 30 minutes, 45 minutes, 30 plus 15, 45 minutes, plus 10, 55 minutes. This 5 minutes I will not consider. So average velocity when you are considering, you will be considering only this, okay, no? Here, 3 kilometers as displacement and time taken will be only 55 minutes. This 5 minutes you will not consider. Are you understanding? May I say you again? There is a person starting from home, gone to market. Market is at a distance of 5 kilometers. He has taken half an hour to reach there. 15 minutes he has, spent in market. Then he started returning back. When he traveled 2 kilometers, he met one friend in the way. He talked for 5 minutes and then he returned home. Now, they may ask any question in this. If for total journey, if they are asking me average speed, the first two words are there. Numerator is total distance covered. Total distance covered is 5 plus 5, 10 kilometers. Total time taken. Total time taken, the time for which person is talking to his friend or person is, spending in market, all time you consider. House to house, how much time he is taking? He has taken half an hour, 15 minutes, 10 minutes, 5 minutes, 20 minutes. All these time you should add. Understanding me now? Clearly? But if you are considering average velocity, time computation, time calculation is same for both. But distance and displacement are different. House to house, displacement is 0. So directly you will say, sir, average velocity is 0. But if they will say that no, compute average velocity from house to that point where he is meeting his friend, then your displacement is only 3 kilometer and time taken will also be changed. For that, then you'll have to take this 30 minute, 15 minute, 10 minute. This 5 minute, the time for which he was talking to friend, you should not consider. Because before talking, he has already reached to that point. Are you understanding this clearly? Yeah? Now, let me take you to next problem. Yeah. Suppose this is a straight line path. Okay? And let us take this is distance S. S1, S2. S1 is moving with V1, S2 moving with V2. Average velocity will be equal to S1 plus S2. Time I told you S1 by V1 plus S2 by V2. Let us suppose a particle has traveled from point A to B. S1 is 1/3 of AB. It is moving along a straight line path. Means AB by 3. If total distance is S, 1/3 distance, it has traveled with velocity V1. And remaining distance, this is 2S by 3, it is traveling with velocity V2. Any numerical data I can give you, it is moving with velocity 40 km per hour, that is moving with velocity 60 km per hour. Then average velocity will be net displacement. Net displacement is S. Now time taken. So for this, time taken is S by 3, this divided by V1. For this, 2S by 3, time taken is V2. Are you understanding? Easy, no? Yeah? If I will consider that, you can easily compute, you can easily calculate. Yeah? Any numerical value they will give you already in homework and all. I have given you this kind of problem. You first understand it clearly how to solve this problem. If they will get, no, particle is moving along a straight line path, S1 with V1, S2 with V2, S3 with V3. Now, compute average velocity. If it is along a straight line path, average speed and average velocity will be same. We will be telling why, sir? Average speed, average velocity, denominator is same, total time taken is same. Only the difference is of net displacement and total distance covered. If particle is moving along a straight line path and it is not returning back, then distance covered and displacement both are equal, right? If they are asking you average speed or average velocity, what will you do? You will be taking S1 plus S2 plus S3 divided by, this is average velocity. Now, time taken, this will become S1 by V1 plus S2 by V2 plus S3 by V3. Is it clear to you? This is nothing but S by, they will give S1, they may give 1/3, 1/3, 1/3, 1/3 also they can give. Whatever value they are giving you, they will supply you 40 km per hour, 60 km per hour, 80 km per hour. Let them give any value, just substitute the values in this, this divided by whatever numerical value they are giving you. Just substitute the value, your answer will come. Are you understanding clearly? Let us take a simple question. I am giving you a straight line path, half distance s by 2, it covers with 40 kilometer per hour from here till here. A to B, 40 kilometer per hour, and next s by 2, it is covering with velocity 60 kilometer per hour. If they are asking you average speed or average velocity, how will you compute? Now, it will be a straight line path, so both are equal. This will be equal to s by 2 plus s by 2, and here it will be s by 2 40. This is nothing but t1, time taken to cover this distance from here till here. Correct now? And now, time taken to cover this s by 2, it will be s by 2 into 60. This will be equal to s you have taken, here s by 2 you take out, it is 1 by 40 plus 1 by 60. Is it clear to you? So how much it will become? This s by 2 here, 40 and 60, 120. So it is 120, 40 3 times, 60 2 times. So this s is cancelled. You are getting 2 into 120 by 5. Clear? 5, 2, 4, 48 kilometer per hour. Understanding now? You have taken a particle moving along a straight line path, half displacement or half distance. A straight line path, no distance displacement will be equal. So half distance or half displacement, it had moved with 40 kilometer per hour. Next half it has traveled with 60 kilometer per hour. What will be mean velocity or what will be average velocity? Simply net displacement by total time taken. And I told you, concentrate mainly on total time taken. Mostly people will concentrate on displacement or distance covered. Displacement is very easy, and that is net displacement. No, I have written s by 2 plus s by 2. You can write directly s. Now, time t1 s by 2 by 40. Time t2 s by 2 divide by 60. And simple calculation, you know, I have done for you. I was thinking to stop here only, but then I thought, why to give work to you? I myself should do for you. Understood? 48 kilometer per hour? You'll be capable to solve now? Yes or no? Yes? Yeah? Now, giving you next question. Suppose I have a particle, it is moving on a square path. I have taken a square. It is moving from A, B, C, D. It has gone from A to B, to C, to D, D to A. With uniform speed V. I have taken uniform speed V, side A, and A. Right? Uniform speed V means A to B, B to C, C to D, D to A. It is taking same time. Now, they are asking you average velocity. If they will ask me for one complete round, A2, B2, C2, D2, A, then again you will say, sir, net displacement 0, average velocity will be 0, sir. But if he'll ask you A to C, okay, no. Again, I told you, concentrate on denominator, time. How much time it will take to move from A to C or A to D. First, I am taking A to C. The A to C time taken will become total distance covered. Total distance is A plus A, 2A, divided by speed is V. So uniform speed is V. It is 2A by V. Now, they are asking you average velocity. So my average velocity is net displacement. Now, A to C, net displacement how much? This is initial position, this is final position. Net displacement is AC. Under root A squared plus A squared. Root 2A. So this is root 2A. Are you understanding this? Or simple Pythagoras theorem you take, na? This is hypotenuse. How much it will be? Under root A squared plus A squared equal to under root 2A squared equal to under root 2A. See here now. Understanding now? Divide by total time taken. In books they will write time only. But when I speak, I am telling about total time taken. You take average speed or average velocity. You take uniform speed, uniform velocity. Everywhere denominator is same. Total time taken. So here, time taken is how much? 2A by V. So this is 2A by V. A cancelled. You got root 2V by 2. It will become V by root 2. Understanding now? Yes? Clear to you? Followed? If they will ask me from A to D, A to D it has gone from A to B to C to D. Your time will change. This one you have taken A to C. If I will take from A to D, I am taking now from A to D. If you will go from A to D, time will be different now, beta. Now it is A plus A plus A. It is 3A by V. Okay? And net displacement also is different now. A to D, magnitude of displacement is A. So, your average velocity will be equal to A by time, 3A by V. So, A cancel. Your answer is V by 3. Is it clear to you? Have you heard about one book? The finest book, one of the best book for solving problems when you will be joining here. Okay? Extra book, undoubtedly our material is the one of the, I will not say best, but one of the finest material we have. One book is there, Problems of Physics by Erudo. Right? Now, in that book, one of the most difficult book for solving problems. First, I will be making you to solve problems only from our resonance material. Everywhere or material is the best material, so from that you will have to solve every problem. After completing, if some extra problem you will have to solve, then Irido book we will be following. In that book, there is a problem related to this. Before concluding today, I want to give that problem for your thinking. You will think and will try to solve. What is that problem? You just see. What a beautiful problem it is. A particle is moving along a straight line path. Okay, now. Suppose it has moved from A to B. This one, along with written homework, this extra work, this is food for your thought. Whatever I have given you concept today about average speed, average velocity, use it and show your intelligence here. How much intelligent you are. A to B along a straight line path it has gone. Half distance s by 2 it has covered with velocity v naught. S by 2 it has covered with v naught. Now remaining, how much distance is left? A straight line path, so distance and displacement are equal. Okay, no? So now remaining is s by 2. Some time it will take now. Let us take, it has taken time t. This point I am giving beta, this point let us take c. Right now. And this distance is your s by 2. Now from c to b, it will take some time. Let us suppose it has taken time t. In this time, for half time, t by 2, it has traveled with velocity v1, and next t by 2, it has traveled with velocity v2. S by 2 with v naught. Next s by 2, it has taken time t. In that half time, it has traveled with velocity v1, and remaining half time, it has traveled with velocity v2. Calculate mean velocity or average velocity for entire journey from A to B. This problem I have given for you to think about this. Same concept, no new concept. Whatever concept I have taught, you'll have to use, but slightly it is tricky. We'll talk about this tomorrow, and similar like many problems in home task I'll be giving you, you'll be thinking about that, right? Tomorrow I'll be solving that. Thank you to all of you. Now you'll have 5 or 10 minutes break, and then your math class will start. Again, thank you to all of you. Have a nice day.
Good afternoon, good morning, everyone. So we'll discuss first yesterday's homework. I think I have given you DPP 2. All right. So we have the questions here, and we'll be discussing one by one. All right. Okay. So which one of the following is true? Pi is a rational number. All rational numbers are irrational number, and all real numbers can be represented on a number line. Right. Now, I already told you pi is an irrational number, right? So the first statement, wait a minute. The first statement, pi is an irrational number, is a wrong because pi is an irrational number, not a rational number. Then second statement, all rational numbers are irrational number. All rational numbers are irrational number, again wrong, they both are different, right? Then C, all real numbers can be represented on a number line. That is true. On a number line, right, we can represent all the real numbers. Rational, irrational, everything comes under this category, right? And then next, root 7 over 8 is a rational number. That is again incorrect because root 7 itself is a irrational number. So root 7 divided by 8 will be a irrational number. That is why it is wrong, right? So the correct answer is what? C. Okay. All right. Next. Just a minute. Which is not a irrational number, right? Which is not a irrational number. So 5 minus root 3. Inside a root there is a prime number. So that's why it is not a irrational number. Sorry, it is an irrational number. Now this is also an irrational number. This is also an irrational number, but this actually root 9 is what? 6 plus 3, which is 9. So that is why it's a rational number, right? It is a rational number. So that's why we'll say it answer is D. Okay. I hope this was clear. Okay. This is again an easy question. Okay, third question, the simplified value of 1 upon 2 plus root 3 minus 5 and 1 upon root 2 minus root 3 minus 5. I think this question, a lot of you will be having doubt about this, right? So let's discuss this, how to solve it. Okay, so what we can do in this, right? I'll try to help you out. So what I'll do, I'll write 1 upon root 2 plus root 3, right, minus root 5. Okay, and plus 1 upon root 2 minus root 3 minus root 5. Okay, so what will happen in this? If I cross multiply, right, if I cross multiply, I'll get the answer to be what? D is 1 upon root 2. Okay, so if I cross multiply, what I'll get? Root 2 minus root 3, okay, and root 2 minus root 3 minus root 5, right, plus root 2 plus root 3 minus root 5. Okay, so from here you will see that root 3 and root 3 will cancel. Root 5, no, you will have root 5 in the numerator and root 2 also. Root 5 will not be cancelling. So you will, and denominator what you will have? Denominator you will have root 2 plus root 3 minus root 5, right, and root 2 minus root 3 minus root 5. Okay, now what I'll do, I will consider this to be as A and this to be B and this to be again A and this to be B. Okay, so what this will become? See, in numerator we will have 2 times of root 2 minus root 5. Okay, and in denominator it will become root 2 minus root 5 whole square minus root 3 whole square, right? Root 2 minus root 5, because I have combined this, as I told, this has to be as A, right? A, and this has plus B and minus B. Okay, so this will become root 2 minus root 5 whole square minus root 3 square. Okay, so if I open, if I apply the square, what will I get? 2 into root 2 minus root 5. In denominator I will have 2 plus 5 minus 2 root 10, right? 2 root 10 minus 3, right? So 7 minus 3 will be now 4, right? 2 plus 5 is 7. So you will have 2 into root 2 minus root 5 into 4 minus 2 root 10, right? If I take 2 root 2 common from denominator, if I take 2 root 2 common from denominator, I will be having 2 into root 2 minus root 5 and 2 root 2 into root 2 minus root 5, right? Now obviously things are cancelling out, so root 2 minus root 5, 2 will cancel, so I'll get 1 upon root 2, right? The correct answer is what? 1 upon root 2, that is already given D as 1 upon root 2, alright? I hope you understand this question. This is a very important question, okay? Again I'll say, okay, here what we can do here is, just a minute. So here we can combine something is okay. This is the next question, I guess. Next, okay, now here I said that we will be combining root 2 plus minus root 5, right, and minus 3, and root 2 minus root 5 minus 3, right? 1 will be plus 3, and so when we solve this, we'll get the answer. Okay, now next question. Fourth, if a plus b equal to 6 and ab equal to 8, then a cube plus b cube equal to what, right? A cube plus b cube, this is an identity. I told you yesterday only that a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b, right? This is one of the formula of a cube plus b cube. We just need to put these values and get the answer. Okay, so I'll be getting 6 cube minus 3 into 8 into 6, right? 6 cube is 216 minus 24 times 6, right? If I do that, I think we'll be getting 216 minus 144, so we'll be getting 72, right? So the correct answer will be what? D, right? This question will was directly based on what? This identity, a cube plus b cube is equal to a plus b whole cube minus 3ab into a plus b, all right? This values we have to substitute after that and you will get the answer. Okay, the next question. Next question is saying, if x plus 1 by x is equal to 3, then the value of x to the power 6 plus 1 upon x to the power 6 is equal to what? Okay, now this question can be done in two ways. One way is we can consider this to be x to the power 6, right, plus 1 upon x to the power 6 can be considered as x square cube, right, plus 1 upon x square whole cube, right? Again, I will apply the formula of what? A cube plus b cube. Just previous slide we have written the formula of a cube plus b cube. So what this will become? This will become x square plus 1 upon x square whole cube, right, whole cube, minus 3 times of x square into 1 upon x square into x square plus 1 upon x square, right? Now x square and x square will cancel, so you will just have x square plus 1 upon x square whole cube minus 3 times of x square plus 1 upon x square. Okay, now what is the value of x square plus 1 upon x square if the value of x plus 1 upon x is 3? So for doing that, I will just square it on both the side, right? If I square it, so I'll get x plus 1 upon x whole square will be equal to 9. It means x square plus 1 upon x square plus 2 is equal to 9, right? It means x square plus 1 upon x square is equal to 7. Right, this is equal to what? 7. So if I put 7 here, I'll be getting 7 cube minus 3 into 7. So if I put the values, right, I think I'll get the answer as 322. Okay, so 7 cube minus 3 into 7 will be what? 322. Okay, all right. Now next question. Evaluate a minus b square upon b minus c upon c minus a plus b minus c square upon a minus b c minus a, c minus a square upon a minus b, b minus c. Okay, all right. So what I'll do here is I will consider a minus b to be x, right, b minus c to be y, and c minus a to be z. Right, a minus b to be x, b minus c to be y, c minus a to be what? Z. Okay, so if I do that, I'll be having x square upon yz, right, plus y square upon zx, right, plus z square upon xy, right, z square upon xy. All right. Now, if I take the LCM, right, LCM, so what I'll be getting? X cube plus y cube plus z cube upon x, y, z, right, upon x, y, z, right. And yesterday I told you that a cube plus b cube plus c cube, right, a cube plus b cube plus c cube, a cube plus b cube plus c cube is equal to 3abc if a plus b plus c is equal to 0. If a plus b plus c is equal to 0. So if I add all the three, right, if I add all the three, I am getting x plus y plus z equal to 0, right, because a will cancel with a, b will cancel with b, c will cancel with c. So x plus y plus z will be equal to what? 0. It means that x cube plus y cube plus z cube is actually will be replaced with 3xyz. And in denominator also we have x, y, z. So this will cancel. The answer will be what? D. X, y. This will be 3. All right. Next. 7th. Find the value of a cube plus b cube plus c cube minus 3abc upon this. This is a just value putting question, right? I have already told you that what is the value of a cube plus b cube plus c cube, right, minus 3abc is actually equal to what? It is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, right? Now if I just replace the numerator with this, right, or if I divide it here, so what I'll get? I'll get a cube plus b cube plus c cube minus 3abc upon a square plus b square plus c square minus ab minus bc minus ca will be equal to what? A plus b plus c. A plus b plus c. And if I just put all the values, right, what I'll be getting? What I'll be getting? It will be getting as a as minus 5, b as minus 6, and c as 10. So this will be minus 1. But if I see in denominator, they have given what? Minus of this, right? So I'll multiply with both sides with minus 1. So I'll get the answer as 1. So the answer is what? A. All right. The answer is what? A. Understood? To get the denominator as ab plus bc plus ca minus a square minus b square minus c square, I need to multiply this with what? Minus 1. So we'll get the answer as 1. Okay. I hope this is clear. Okay, next question. Okay, if x equal to 1 upon 1 plus root 2, then the value of x square plus 2x plus 3 is equal to what? Right? In school time, you must have learned that whenever there is a surd given, 1 upon 1 plus root 2, right, we can actually rationalize this. So how will I rationalize? This can be written as 1 upon root 2 plus 1, right? And now if I rationalize this, so root 2 minus 1 and root 2 minus 1. So this will become what? Root 2 minus 1 upon root 2 square minus 1, right? This is x. So basically you will have x is equal to root 2 minus 1 upon 2 minus 1. It means that x is equal to root 2 minus 1. Right, x is equal to what? Root 2 minus 1. Now always remember, in this kind of question, when you have one root and one as a normal rational number, you always send the rational number on the side of variable. So we will have x plus 1 will be equal to root 2, and then square it, right? Squaring. So after squaring, what will happen? This will become a quadratic and this will become a proper rational number. So if I square it, I will be getting x plus 1 whole square is equal to 2, right? It means that x square plus 2x plus 1 is equal to 4, right? X square plus 2x plus 1 is equal to what? 4. So I can say that x square, sorry, it is equal to, this will be equal to 2, right? This is not 4, this will be equal to what? 2. So x square plus 2x will be equal to what? 2 minus 1, which will be equal to 1, right? Which will be equal to 1. So if I put here 1, right? So 1 plus 3, instead of this is what? 1 plus 3. So answer is what? 4. Understood? The correct answer is what? 4. So always remember how to solve this kind of question. Now next, 9. Consider the following statements, right? The sum of a rational number with an irrational number is always irrational, right? I gave a note yesterday. The first statement is true, that sum of a rational and an irrational number is always going to be a what? Irrational number. So the first statement is correct. It is self-explanatory, okay? The second statement, the product of two rational number is always a rational number. Again, it's a correct statement, okay? If I multiply two rational number, then I'll be getting a rational number. Third, the product of two irrational is always irrational. Now that itself is not correct. Why? Because let's say if I multiply 2 root 2 into root 2, right? So I'll be getting what? 4, right? So this is an irrational number, this is also an irrational number, but this is a rational number, right? So the third statement is not correct, okay? Next, the sum of two rational, okay, is always rational. That is true. The sum of two rational number is always going to give me a rational number. So it is also true. Fifth, the sum of two irrational is always irrational. Okay, the sum of two irrational is always irrational. Why it is wrong? Because see, if I write 1 plus root 2, right, plus 1 minus root 2. So what I am going to get? 2, because root 2 and root 2 will cancel. So what the answer will be what? 2. And 2 is what kind of number? 2 is a rational number. But they are saying it is always irrational. This last statement is also wrong, right? So the correct answer will be what? Option C, because the first two are true, third is false, and fifth is false. So the correct answer is what? C. Okay? Okay, let's go to the next question. Next. 10th. Which of the following is an irrational number, right? So the first is actually simplified into 2 by 3, right? This will also be 2 by 3 because it is a cube root, right? 22 by 7 is actually written in the form of P by Q, right? So it's also a rational number, all right? Only C. In C, if you see, 7 upon 22 is a rational number, right? But pi is a irrational number. So rational into irrational will always give me what? Irrational. Not always, but in this case it is giving me what? Irrational. So the answer is what? C. Okay. Next. If P comma Q belongs to natural number and 0.12 bar equal to P by Q, where P and Q are relatively prime, then identify which of the following is incorrect. Which of the following is incorrect? So how will you solve this kind of question? We'll say let x equal to 0.12 bar, right? 12 bar. So 10x will be equal to what? If I multiply with 10, I'll be getting 1.22 bar, right? 1.22 bar. And if I subtract them, right? If I subtract them, what I'll be getting? 9x, right? 9x will be giving me what? 2 bar will cancel, so I'll be having 0.1, and so here 1.1, right? So x will be equal to what? 1.1 upon 9, right? If I multiply with 10 on both sides, numerator and denominator, I'll be getting x is equal to 11 by 90, right? Because they are saying p and q are both natural numbers. So p and q are relatively prime also, because 11 and 90 doesn't have any common factor. So what is the correct option in this, right? So the following is incorrect. P is a prime number, right? P is a prime number is a correct statement, right? P is a prime number. Second, Q minus P is a prime number. If I subtract 90 with 11, right, I am going to get 79, right? 79. So it is not a prime number. It is a prime number, right? It is also correct. Then Q plus P will be how much? 90 plus 11, which is going to be 101, right? That is also a prime number. So this is also correct. Then Q is a prime number. 90 is not a prime number. 90 is not a prime number. So that's why this is the incorrect statement. So the correct answer is what? D. Okay. All right. Next. If a plus b plus c is equal to 3, then the value of a plus b plus c equal to 3x. Then the value of x minus a, x minus b, x minus c minus 3x minus a, x minus b, x minus c is equal to what? Okay. All right. So see, in this case, if I bring all, they have given us a plus b plus c is equal to 3x, right? A plus b plus c is equal to 3x. If I bring all this on one side, I'll be getting 3x minus a plus b plus c is equal to 0, right? 3x minus a plus b plus c is equal to 0. Now, if I split this 3x into 3x, x, x and x, and give each x to this minus a, minus b, minus c, what this will be simplified in? It will be simplified in the form of x minus a, right, plus x minus b plus x minus c is equal to 0, right? X minus a, x minus b, x minus c equal to 0. Now, if I say, let's say this is p, this is q, and this is r, so what it is written? P plus q plus r equal to 0. And if p plus q plus r equal to 0, can I say that p cube plus q cube plus r cube minus 3pqr will be equal to 0, right? Will be equal to 0. Why? Because actually pq plus q cube plus r cube minus 3pqr is actually equal to what? It is equal to p plus q plus r into p square plus q square plus r square minus pq minus qr minus qp, right? Since this is 0, I can say that this will also be equal to 0. Understood? The correct answer here is what? A. All right. Let's go to the next slide. The number of real roots of the equation x minus 1 square plus x minus 2 square plus x minus 3 square is equal to what? Right? X minus 1 square. So this is actually a quadratic equation question. What you have to do is here that x square, we have to expand this, so x square minus 2x plus 1 plus x square minus 4x plus 4 plus x square minus 6x plus 9 equal to 0, right? Now what you will have, you have 3x square minus 2x minus 4x is minus 6x, minus 6x and minus 6x will become minus 12x, right? And this 1 plus 4 is 5, 5 plus 9 is going to be how much? 14 is equal to 0, right? Now they are asking how many real roots are there. Okay, so one way of doing this question is what? One way of doing this question is that we can find out D. What is D? D is B square minus 4AC. And if it is less than 0, then we say there is no real roots. If it is more than 0, we'll say it is 2 real roots. If it is greater than 0, we will say 2 roots. So when we find out, we'll get 144, right? 12 square is 144 minus 4 into 3 into 14, right? So it is 144 minus 12 into 14, which is going to be negative, So we will say that there will be 0 real roots, right? Now this is a very standard approach of doing this question, but there is also one smart way of doing this question. What is the smart way? Let's understand, right? So all of us know that square of any natural number or a real number, square of any real number is always going to be greater than or equal to 0. It means that it cannot give us a negative value. It cannot give us a negative value. If it cannot give us a negative value, then what I can say that none of these 3 terms are going to be negative. None of these 3 terms are going to be negative. And still their sum is equal to 0. Their sum is equal to 0, right? Then what could be the possibility that if see any one of them is positive, then something has to be there na, to cancel it, to subtract it, to become it to 0, right? But none of them can be negative. So that's why if sum of 3 non-negative quantity, right, is 0, then I will say that all of them x minus 1 equal to 0, x minus 2 equal to 0, right, and x minus 3 equal to 0. But simultaneously all of them cannot be 0. Why? Because this first one is saying x is equal to 1, second one is saying x is equal to 2, third is saying x is equal to 3. How can 1x only will become 1 also, 2x also, and 3 also? So that's why there is no real root for this equation. Alright, so this is a very smart way of doing the question, but if someone doesn't know it, then he can always do from quadratic equation, right? This concept you must have learned in 10th, but if you don't know, then we will learn in quadratic equation, which is going to be the next chapter. Okay, I think next or next. Okay, then second last question, 14th, if x plus 1 by x equal to 5, then x cube minus 5x square plus x plus 1 upon x cube minus 5x square plus 1 upon x cube is equal to what? I think there is a printing mistake here. This is going to be just x, right? This is going to be just x. Okay, so what I need to find out, see I can club x cube and 1 upon x cube and minus 5x square and minus 5 by x square. So what this will be becoming? It will be becoming x cube plus 1 upon x cube, right? And minus 5 into x square plus 1 upon x square, right? And this is going to be plus x plus 1 by x, right? X plus 1 by x. Now all of their individual values we can find. This to directly is going to be 5, right? For this I can write, so for this one, first I will write x plus 1 upon x cube minus 3 into x plus 1 by x, right? Then minus 5 times of x plus 1 upon x whole square minus 2, right? And then last I will be having plus x plus 1 by x. I can just put the value of x plus 1 by x as 5, right? Because they have given 5, so what I'll get? I will get from here 5 cube, that is 125, minus 3 into 5, right? Minus 5 times of 25 minus 2, right? And plus 5. Okay, I think if you solve this, whatever the answer you will get, this answer is going to be what? 0. Okay, this can be equivalent to what? 0. Understood? Okay, then the next one, simplify the value of this. Okay, now this question is also very interesting because a lot of students must be having confusion in this. Okay, so if you want to simplify this question, okay, so what I'll do, see, I will say let A equal to 3.75 and B is equal to 1.25, right? A equal to 3.75 and B is equal to 1.25. If A is this and B is this, then what will be the simplified version of this? This will become C. It will become A square, right, plus B square minus 2AB, right? A square plus B square minus 2AB, and in denominator it will be what? It will be A square minus B square. Am I correct? Okay, so this will become A minus B whole square upon A minus B into A plus B. Now this and this will cancel, right? Now what will be A minus B? A minus B will be, I think, 2.5, right? A minus B is how much? 2.5, and A plus B is going to be 5. So this is going to be how much? Half, which is 0.5, right? Which is going to be what? 0.5. So this is the correct answer. All right. I hope all these things are clear, right? So we have completed all the homework. Apart from this, I have given you one more homework. Yesterday, we'll discuss it. I think it will be coming in next questions also. So I think if some of you remember, x to the power 5 plus 1 upon x to the power 5 equal to what? Okay, those who in terms of x square and x cube, right? So those who have got the answer, it's fine. Those who have not got, they can try it for 2 minutes. We'll discuss it. Okay. Along with this, we'll learn something new also. Okay. So x to the power 5 plus 1 upon x to the power 5. How we will get this? See, if x to the power 5 plus 1 upon x to the power 5, right? So obviously what I'll do, I will multiply x square plus 1 upon x square and x cube plus 1 upon x cube, and we'll see that what I'll get. Okay. So if I multiply this, so I'll be getting x to the power 5, right? X square with 1 upon x cube, I'll get 1 by x, right? 1 by x. Then 1 by x square into x cube will give me x, right? And 1 by x square with this will give me what? 1 upon x to the power 5, right? So can I say that this will be simplified to x to the power 5 plus 1 upon x to the power 5, right? Plus x plus 1 by x. Understood? So from here, I will get a result that x to the power 5 plus 1 upon x to the power 5 will be equal to x cube plus 1 upon x cube into x square plus 1 upon x square minus x plus 1 upon x, right? So because I will send this that side, and I'll get the value of this value in terms of x plus 1 by x. Understood? This was one more question. If you must be watching the class, then definitely you I have told you to discuss this question. Okay. So we'll do the next topic now. Today's topic, which is polynomials. Okay. Now we'll discuss the next topic, which is polynomials. Okay. Polynomials. Now what is a polynomial, right? Anything written in terms of a variable and number, right? Like if suppose I write this, p of x is equal to a naught plus a1x plus a2x square plus a3x cube, so on, right, till an x to the power n. Okay. Now this thing is a polynomial. All right. This will be classified as a what? Polynomial in x. Right, because there is a variable here, what? X is the variable. So this will be said as a polynomial in x. Okay, polynomial in x. All right. Okay. Now in this, the highest power of the variable, highest power of x, right? Power or exponent, whatever you call it, will be known as what? Degree of polynomial. Will be known as what? Degree of polynomial. Okay, so in this case, the highest power is what? N. right? This is the first point to understand, that highest power of x will be known as what? Degree of polynomial, right? So in this case it will be what? N. Understood? This case it is what? N. This is the first point about the polynomial function. The second thing is that, right, a0, a1, a2, so on till an, right? They are real coefficient. They are going to be what? Real coefficients. Right, real coefficient. Just for suppose a0 is a constant term, right? It is a constant term. A1 is a coefficient of x. A1 is what? Coefficient of x. A2 is what? Coefficient of x square, right? And so on. An will be coefficient of x to the power n, right? X to the power n. Okay, well, this is the second point to remember, right? This is polynomial. So in polynomial, how does polynomial look like? It looks like a0 plus a1x plus a2x square plus a3x cube, so on till an x to the power n. It is known as polynomial in terms of x, right? And highest power of x is known as the degree of the polynomial. And this a0, a1, a2, a3 are known as what? Real coefficient. a0 is known as the constant term. A1 is coefficient of x, a2 is coefficient of x square, and an is coefficient of x to the power n. Am I clear? Okay, now we'll go to the next part. Okay, so I'll take some examples, okay, and tell that whether this is a polynomial or not. Okay, so so I'll write root 3 x square, right, plus x minus 5. Right, this is the first example. Second example is that root 3 x square plus root x minus 5, right? And third, 5x cube plus 2x square plus 3x minus 5 by x. Okay, now before coming to this, there is one more point here which I missed, that the exponent of x belongs to n, right? The exponent always has to be what? A natural number. Okay, it cannot be a irrational number or a complex number. All right. So now let's come to this part, or a negative number also. Okay, so in the first one, if I see x square is given and x to the power 1 is given, right? So can I classify this as a polynomial? Yes, this is a polynomial. Okay, second one, they have given, see, this is the power is 2, but this power is actually what? X to the power half. So that's why it will not be classified as what? Polynomial. Okay, in second one, if I simplify this, I'll be getting 5x cube plus 2x square plus 3x minus 5 x to the power minus 1, right? Minus 1. So till here it was a polynomial, right? But if I extend completely, there is a negative power, and because of this negative power, this will not be classified as what? Polynomial, right? Because in polynomial, the exponent of x always has to be a natural number. All right, now let's go to the next part. Okay, now I'll write few examples and you have to tell me the degree of that particular polynomial if it is defined, right? The degree of the polynomial if it is defined. So first is 3x to the power 4 minus 5x square plus 2, right? Second is 5x to the power 4 plus 2x to the power 5 minus 3x plus 7, right? And last, it is going to be 2x cube plus 7x minus 5, right? So you have to tell me the degree. You have to write the degree of the polynomial. So in this case, the first one, which is the highest power of x. So this is 4, right? So highest power of x is what? 4. So degree of this polynomial will be what? 4. All right. In the second one, the degree highest power is what? 5. So we'll say its degree is what? 5. Okay. In third one, what is the degree of this polynomial? It is 3. It is very simple to understand. So the highest power is here is what? X. sorry, the highest power is here is what? 3. Understood? So this is about degree of the polynomial and identification of polynomial. All right. Now you can identify the polynomial based on this. Now we'll go to the next topic. Okay. The next topic is classification of polynomial. Okay. Classification of what? Polynomial. Okay. So if I do that, classification of polynomial, right? So the first type of classification is based on the number of terms in the polynomial. All right. So first classification, first type is based on number of terms. Number of terms. All right. So the first thing is in that is monomial. Monomial. So if I write px is equal to 3x, right? Px is equal to what? 3x. Now this is what? This is a monomial. Why? Because mono means one, right? So it has only one term. That's why we'll say it's a monomial. Okay. Then second, binomial. Second is what? Binomial. Okay. In binomial, if it is written as px equal to, suppose if I write 3x plus 5, right? 3x plus 5. So this is called a binomial because there are two terms, right? So this is going to be a binomial. Then third, it is a trinomial, right? Trinomial. So in trinomial, we can write px is equal to 3x square plus 2x minus 1. So this is going to be what? Trinomial. Understood? So the first type of classification of polynomial will be in terms of number of terms, monomial, binomial, trinomial. The name themselves are saying what is the number of terms. Okay. The second type of classification, okay, the second types of classification is based on degree. Based on degree of polynomial. This one is important. Right, based on degree of polynomial. So in this first one is 0 degree polynomial. 0 degree polynomial. Okay, so we can say just p of x is equal to some number a. Right, there will be no exponent of x in this. So that's why it is known as 0 degree polynomial. Okay, because we can add it to be a into x to the power 0 also. So that's why we say it's a 0 degree polynomial. All right. Second, you must have heard it, linear polynomial. Linear polynomial. In linear polynomial, what will be there? So there will be the highest power of x will be how much? 1. So it will be in that, it will be looking like this, 2x plus 5. Right? 2x plus 5. So in general, a linear polynomial will look like this, ax plus b. Okay. This is known as what? Linear polynomial in which a can't be equal to 0. In which a can't be equal to what? 0. Then third, quadratic polynomial. Right? Quadratic polynomial. So we all know what does a quadratic look like. Px is equal to what? Ax square plus bx plus c. Where a can't be equal to 0. Why? Because if a equal to 0, then this will become a linear. Bx plus c is what? Actually a linear polynomial. So that's why this a, which is coefficient of x square, cannot be equal to what? 0. Okay. Then fourth, cubic polynomial. Cubic polynomial. All right. This will look like this. So px equal to what? Ax cube plus bx square plus cx plus d. Okay. In this also, a will not be equal to what? 0. In this also, a will not be equal to 0. Why cubic? Because the highest power is here what? 3. Okay. Mind it that only a can't be 0 in all of them. B and C, there is no restriction on B, C and D. It means they can be 0, negative, rational, irrational. Any kind of real number is okay for that. Alright. Then next, then last one, which is known as biquadratic polynomial, right? Which is known as what? Biquadratic polynomial. Okay, in this case, n will be equal to 4, right? So it will look like this. P of x is equal to ax to the power 4 plus bx cube plus cx square plus dx plus e. Understood? So this will be a biquadratic polynomial. Again, here also a cannot be equal to 0. Okay, here also this a, also known as a leading coefficient. Okay, this highest power coefficient, highest degree term coefficient is known as what? Leading coefficient. This cannot be equal to 0 in any of them. Alright, so these are a classification of polynomial based on it. First is on number of terms, monomial, binomial, trinomial, right? And second one is based on the degree of the polynomial. 0 degree polynomial, linear polynomial, quadratic polynomial, cubic polynomial, or last one is biquadratic polynomial. So I hope till now you have understood everything about the polynomial. What is a polynomial? What is a degree of polynomial? Right? How can we classify a polynomial based upon number of terms and based upon the degree of the polynomial also. Okay. Now we'll do the next part. Okay. Now there are two important theorems based on the polynomial. All right. So we'll understand those two theorems of polynomial. Important theorem on polynomials. Right, important theorems on polynomials. The first one is value of a polynomial. Is value of a polynomial. All right. It's very simple. Let's say if I define any polynomial as x cube minus 3x square plus 5. Right? X cube minus 3x square plus 5. And if I ask you what is the value of this polynomial at x is equal to 2. Okay, at x equal to 2. So basically what you have to do, in place of x you have to write 2 in this polynomial. So what are they asking? We can say p of x equal to 2, or we can directly say p of 2, which will be equal to what? 2 cube, right, minus 3 into 2 plus 5, which will be how much? 8 minus 6, sorry, this is square, right? So this is going to be 12. 8 minus 12 plus 5, so which is going to be what? 1. So the value of polynomial px at x equal to 2 is actually how much? 1. Understood? So this is the first thing, value of polynomial. What you will do, in place of x, wherever there is x in the polynomial, you will put the value, right? And you will get the answer. Okay. Next, second. So you understood value of polynomial. Now second is 0 or a root of polynomial. 0 or root of polynomial. Alright. So what does 0 or root of a polynomial means? What does actually it means? So p of x, right? Let's say p of x is equal to what? X square minus 3x plus 2. Okay? X square minus 3x plus 2. So that value of x, the value of x for which this value, the value of polynomial becomes 0, is known as root or zeros of a polynomial. So I'll add the definition. The value of x for which p of x becomes 0 is what? 0 or root of polynomial. So in this case, how to find a root? Best way to find a root is that you equate it to 0. Okay, and then you can get the value of x, right? So in this case, you will be having x is equal to 1 and x is equal to 2 as a root of this equation. We also say it as a root or we say it as a 0, right? You can check also, how did I get this x is equal to 1 and x equal to 2? There are multiple methods to solve the quadratic equation, but currently we are looking for what? The meaning of zeros or root. How? So see, if I put p of 1, so what I'll get? 1 minus 3 minus 1 plus 2, it is equal to 0. And if I also put 2, so I'll get 2 square minus 3 into 2 plus 2, which is also equal to 0. So there is how many roots? There are 2 roots of this particular quadratic polynomial. It is how much? 1 and 2. And to find the roots, what I'll do? I will just equate this thing to be equal to what? 0, right? So I hope you understand what is a 0 or a root of a polynomial. Now the next part. The next part is remainder theorem. Remainder theorem. Right. Now remainder theorem is very interesting. Now what does actually remainder theorem states? Right. Suppose there is a polynomial, right? X cube minus 6x square plus 11x minus 7. Right, x cube minus 6x square plus 11x minus 7. And I need to find a remainder. I need to find a remainder when this polynomial, right, this polynomial is divided by x minus 1. Okay, is divided by what? X minus 1. So what I will do, whatever is the root of this divisor, whatever is the root of this divisor, I will just plug in that value of x in this. Okay, whatever is the root of this divisor, I'll plug in that value of x in this p of x, and I'll get the remainder. Okay, so what is the root of this? I told you to find the root. What I'll do, I'll equate it to 0. So I'll get x is equal to 1. Right, the root of x minus 1 divisor is what? X equal to 1. So I can just plug in the value of x here. So I'll get p of 1 to be equal to 1 minus 6 plus 11 minus 7, right? So 1 plus 11 is how much? 12, and minus 6, so it is going to be 12 minus 13, it is equal to what? Minus 1. Okay, so the remainder when x cube minus 6x square plus 11x minus 7 is divided with x minus 1. Okay, with x minus 1 is going to be what? Minus 1. Okay, now if they are saying I want to find the remainder when this p of x is divided with x plus 1. It is divided with what? X plus 1. Then what is the remainder? To find that, I will first find the root of this. Right, so what is the root? X is equal to minus 1. What is the root? X is equal to minus 1. Now that value I'll plug in here. So p of minus 1 will be how much? Minus 1 cube minus 6 into minus 1 square plus 11 into minus 1 minus 7. Right, so this is going to be minus 1 minus 6 minus 11 minus 7. Right, so this is how much? Minus 14 minus 11, which is going to be minus 25. Understood? So the remainder when x plus 1 divides what? This is going to be how much? Minus 25. Understood? I hope it is clear about remainder theorem. Now the extension of remainder theorem only, okay, the definition I am not giving because it's already given in the book. I will only explain you what is the remainder theorem. Now I will do what? Factor theorem. Okay, the last theorem on polynomial, then we'll do examples. Okay, so factor theorem, fourth one. Factor theorem. Now what does factor theorem states? Right, suppose I am taking the same example, p of x is equal to what? X cube minus 6x square plus 11x minus 6. X cube minus 6x square plus 11x minus 6. And I say, let's say x minus 1. X minus 1 is a factor of this polynomial. It's a factor of this polynomial. So what I will do, whatever is the root of this particular divisor, that is x is equal to 1, right? On substituting that value in p of x, on substituting that value of p of x, I'll be getting 0. Okay, so let's check. So P of 1 if I put, so 1 minus 6 plus 11 minus 6. So this is going to be 0. It means that if P of 1 is 0, it means x minus 1 is a factor of this, right? So I can say in general, if P of alpha is equal to 0, right? If for any polynomial P of alpha equal to 0, then x minus alpha is a factor of P of x. Then x minus alpha is what? Factor of P of x. Similarly, can you check whether x minus 2 is a factor of this? Check whether x minus 2 is a factor of this or not, right? Again, what will I do? I will just put the value as 2 and check whether it is becoming 0 or not. If it is becoming 0, I will say it's a factor. So if I check for 2, it will become 8 minus 6 into 4 plus 11 into 2 minus 6, right? So I'll get 8 minus 24 plus 22 minus 6, which is going to be 30 minus 30, which is going to be 0. So I can also say that if P of 2 is 0, I will say x minus 2 is a factor of P of x, right? Remember this, if P of alpha is 0, then x minus alpha is a factor, not x plus alpha. Many students does the same mistake that they take x plus alpha as a factor rather than x minus alpha. Understood? All right, let's do now questions based on this. Okay, we still have 25 minutes left. I hope you understand all the 4 theorems based on the polynomial. Now let's do some questions based on this and then I'll give you the homework. Okay. All right. So the first question is that if x is equal to 4 by 3 is a root of polynomial fx is equal to 6x cube minus 11x square plus kx minus 20, right? Then k equal to what? Then k equal to what? Okay. So if x is equal to 4 by 3 is the root of this polynomial, then k equal to what? It is very simple. What will I do? If any number is a root of this polynomial, I will just substitute that value, right? And on substituting that value, I should be getting what? 0. So if I do it, I'll be getting 6 into 4 by 3 cube, right? Minus 11 into 4 by 3 square plus k into 4 by 3 minus 20 is equal to 0, right? If I simplify this, I'll get 6. Okay, I think I can reduce this. So it is 6 into 64 by 27 minus 11 into 16 by 9 plus 4k by 3 minus 20 is equal to 0. I think this will cancel with 9, right? So you will have 128 minus 16 times 11 is how much? 176 plus 3 times plus 12k minus 180 is equal to 0, right? From here, I think you will have k is equal to 12k is equal to 128 minus 176 minus 180. This you will need to do the calculation, right? It will become 228. So k will be equal to 228 divided by 12. So k will be equal to 19. Right? K will be equal to 19. Understood? K will be equal to 19. I hope this example is clear to all of you. If x is equal to 4 by 3 is a root this. If anything is a root of the polynomial, just plug in the value and say that that thing will be becoming 0. Or we also say it will satisfy the given polynomial. Satisfy means it will become 0. All right. Next question. If x equal to 2 and x equal to 0 are two roots of two roots of p of x are two roots of p of x is equal to 6x cube minus 11x square. No, I think I made a mistake. It is 2x cube minus 5x square plus ax plus b, right? 2x cube minus 5x plus ax plus b, then a comma b is equal to what? Then a comma b is equal to what? So what I'll do, if again these two are the roots of this equation, they have to become what? 0. On substituting them, p of x will become what? 0. So if I put p of 2, what I'll get? 2 into 2 cube minus 5 into, I think it's square. Yes, it's a square. So minus 2 into square plus a into 2 plus b should be equal to 0. Right? So what I'll get from here? 16 minus 20 plus 2a plus b is equal to 0. It means 2a plus b is equal to 0. No, 2a plus b is equal to 4. 2a plus b is equal to how much? 4. And also they have given p of x equal to 0 is the root of this equation. So can I say p of 0, which is just 0 minus 0 plus b will be equal to 0. So from here I will get b is equal to 0. Right? What will I get? I will get b is equal to 0. If b is equal to 0, I can substitute it here, right? And I'll get 2a is equal to 4. So a will be equal to how much? A will be equal to 2. Understood? So they have asked the value of a and b. So a is 2 and b is how much? 0. I hope this is clear to all of you. Okay, a and b. Now next question. Example. So both the examples were based on roots. So if they have given the roots of any equation, we will satisfy that in the given equation and get the value of what? Any particular coefficient, if anything is missing. Okay, next. Find the remainder. Find the remainder when fx is equal to x cube minus 6x square plus 2x minus 4, x cube minus 6x square plus 2x minus 4, if it is divided by 1 minus 2x, is divided by 1 minus 2x. Okay. So again, they have clearly mentioned here what do we need? We need to find what? Remainder. So if I want to find the remainder, right? So what I will do, whatever factor they have given, whatever factor we have given, we'll first find its root, right? We'll first find its root. So 1 minus 2x equal to 0, right? 1 minus 2x is equal to 0. So what I'll get? I'll get x is equal to half as the root of this factor, right? I'll get x equal to half as the root of this factor. Now that root, I'll plug in it here and I'll get the remainder, right? So if I put it here, I'll get f half will be equal to half cube minus 6 into half square plus 2 into half minus 4. Right? How much? Minus 4. So if I do that, what I'll get? 1 by 8 minus, this will be 6 into 1 by 4 plus 1 minus 4. Right? So if I take LCM, I'll get 1 minus 12 plus 8 minus 32. Right? So what is the answer? What is the answer here? Minus 32. So I'll be getting, divided by 8 is also there. So I'll be getting minus 35 by 8. Right? I'll be getting minus 35 by 8. Understood? This is going to be the answer for this question. Okay. Again, I'll repeat what I have done here. So if I need to find the remainder of fx, right, divided by any particular factor, I will first find out where it is becoming 0, right? Wherever it is becoming 0, that value I will plug in the given particular polynomial, and that will give me directly the remainder of the polynomial. So if I just put half, right, so I'll get half cube and the calculation, and then I got this as a remainder of this. Okay. Next question. Now the polynomial ax cube plus 3x square minus 13 and 2x cube minus 5x plus a are divided by x plus 2 and divided by x plus 2, and if the remainder is same, right, then find the value of a. Then find the value of what? A. Okay. So the polynomial ax cube 3x square minus 13 2x cube minus 5x plus a. What I can do is I'll say let fx is equal to what? Ax cube plus 3x square minus 13 and gx is equal to what? 2x cube minus 5x plus a. Right? Fx equal to this and gx equal to this. Okay. And now I need to divide both of this by what? X plus 2. I have to divide both of this with what? X plus 2. So what I'll do, I will find the root of x plus 2. So x plus 2, to do that, I will equate it to 0. So I'll get x is equal to minus 2. Right? What I will get? I will get x is equal to minus 2. Now that value I'll plug in both f and g. So f of minus 2 is how much? Minus 8a, right, plus 12 minus 13. So I'll be getting minus 8a minus 1, right, and g of minus 2 will be equal to minus 16 minus plus 10 plus a, right. So I'll be having here a minus 6, right. What I'll be having? A minus 6. Now what they are saying, these are the remainders in both the cases. Now they are saying minus 8a minus 1 is equal to what? A minus 6 is equal to what? A minus 6. So what is the value of a? To do that, what I'll do, I'll bring it here, that side. So I'll have 6 minus 1, that is 5, is equal to 9a. So it means a is equal to what? 5 by 9. Understood? A will be equal to what? 5 by 9. Understood? So what I did here is, they have given the two polynomials and they have divided by a same common factor. What is that factor? X plus 2. Right? They have divided both of them with what? X plus 2. And if they are on dividing, they are saying that they are getting the same remainder. So again the word constantly remainder and remainder is repeated. Whenever they are repeating the same word, it means remainder theorem will be, remainder is used, that's why we'll say remainder theorem will be used, right? And on applying remainder theorem, in both of them, we equated the remainders and we got the value of a to be how much? 5 by 9. Understood? Now let's do the last example and then I'll give you the homework. Okay, for tomorrow. The last question. What is the last question? The polynomial ax cube plus 3x square minus 3, ax cube plus 3x square minus 3 and 2x cube minus 5x minus a right? 2x cube minus 5x plus a on dividing with x minus 4 leaves a remainder R1 and R2 respectively. Then find the value of A. If 2R1 minus R2 is equal to 0. If 2R1 minus R2 equal to 0. So I'll give you 2 minutes to solve this question. Okay. This previously based question, only this time they have given 2R1 minus R2 equal to 0. Right. It means what? 2R1 will be equal to R2. Understood? So please solve this question. We'll discuss in 2 minutes and then I'll give you the homework. Okay, I hope all of you have applied the remainder theorem. Okay, so I will also start doing it. I've given you 2 minutes. Okay, so see, again they are dividing it with what? X minus 4. Okay, so what is the root of x minus 4? I need to find out. So x minus 4 I'll equate it to 0 and I'll be getting what? X is equal to 4. Right, I'll be getting x equal to 4. Again I'll say this to be fx. So fx is what? Ax cube plus 3x square minus 3, and gx is what? 2x cube minus 5x plus a. Right, and I'll put 4 in it. So if I put 4 in this, I will get a into 4 cube plus 3 into 4 square minus 3. Right, so which will be 64a. Right, plus 16 times 3 is 48 minus 3. So I'll be getting 64a plus 45. Right, now this is the remainder. This is the remainder when I divide fx with what? X minus 4. Right, this is the remainder when fx is divided by what? X minus 4. And that remainder they have mentioned it to be what? R1. Understood? That remainder they have given it to be what? R1. Now what I'll do, I will also find R2. So to find R2, I will also put g of 4 in this. So if I put it, I'll get 2 into 4 cube minus 5 into 4 plus a. Right. So I'll be getting 2 into 64 minus 20 plus a. So it will be becoming 128 minus 20 plus a. Right, which is what? 108 plus a. Right, this is what? R2. This is what? R2. So we have R1, we have R2, and we also know the relation 2R1 equal to R2. Right, we also know the relation 2R1 is equal to R2. So we'll try to use this. What I'll do, I will write it here. So 2 times of R1, which is 64a plus 45 is equal to what? 108 plus a. Right, 108 plus, I'll come from this side. It will be 108 plus a. So it is 128a plus 90, right, is equal to 108 plus a. If I bring a that side and 90 that side, I'll get 127a is equal to 18. Right? Because 108 minus 90 is how much? 18. So now I'll have a equal to 18 divided by 127. Right? I think this can be simplified. This can be simplified 18 is 2 into 9 and 127. I don't think they will be divisible by any of this. So the correct answer will be what? 18 by 27 only. Right, 18 by 27. They don't have any common factors. So that's why we'll keep it here only. And this should be there in the option if it comes in the option. Okay. So I hope all these things is clear about the polynomials. I will now revise it and will give you the homework. Whatever we have done in today's class, we'll revise and I'll give you the homework for it. Okay. So first of all, we'll discuss yesterday's homework and then we'll discuss what is a polynomial, right? So a polynomial is what? A polynomial is an expression in terms of a variable with real numbers. Okay, and it is in polynomial in terms of x. Highest power of x is known as n, and this highest power x coefficient is known as the leading coefficient. It is known as what? Leading coefficient, and this cannot be equal to 0. That is, this leading coefficient cannot be equal to what? 0. And this a0, a1, a2, so on are known as real coefficient, where a0, in which there is no x, is known as constant term. A1 is coefficient of x, A2 is coefficient of x square, An is coefficient of x to the power n, right? And the exponent of, all the exponent of x should be a natural number for it to be a polynomial. And the highest power of x is known as a degree of the polynomial. So in this case, the highest power is what? N. Okay, next, so root 3x square plus x minus 5. We saw that why these two are not polynomial, because this has a rational power and this has a negative power. Understood? Now this one, we identify the degree of the polynomial. What are the degree of the polynomials? Then classification of polynomial based on number of terms, monomial, binomial and trinomial. Then 0 degree polynomial, based on the degree of the polynomial also we have classified the polynomial. 0 degree polynomial, linear polynomial, quadratic or cubic. Understood? There is one more, biquadratic polynomial also. Understood? Next, value of a polynomial, right? To find, this is the theorem based on polynomial, based on which we have done some questions. So to find the value of any polynomial, what I'll do, I will just plug in the value of x in that polynomial and I get the value. So in this case, if I have put 2, I got the value as 1. Right? Then next, 0 or root of the polynomial. If on substituting any value of x, right, I am getting the value of polynomial to be 0, we say it's a 0 or root of the polynomial. So I've given the definition also. The value of x for which px becomes 0 is known as 0 or root of the polynomial. Then remainder theorem, to find the remainder of any particular polynomial on dividing with some other polynomial, I just need to find the root of this polynomial and substitute it here. Right? So we have seen this example. Then factor theorem, if on substituting any value, I am getting the remainder as 0, it means it is a proper divisor and we can say that it will be a factor of the given polynomial. Alright, so we have done some question based on this. Now I will be giving you homework from your CBC only, worksheet day 3 worksheet. Okay, worksheet, I think it will be on page number 59, yes. Okay, page number 59. Page number 59, and total question numbers are, right, all 15 questions. All 15 questions. So yesterday I have given you day 2, now this time I'll be giving you day 3. Right? All 15 questions, these are homework for today, and we'll discuss it tomorrow before starting the new topic. And I think tomorrow we'll wind up number system. Okay, so the last topic is remaining, ratio and proportion and their properties, and then we'll finish it off. All right, thank you everyone. Good.